Good morning. All right, let me know when y'all are done climbing over the furniture back there. No. Did everybody have a good time last night? It's actually a pretty good turnout this morning, all things considered. Yeah, I hope everybody remembered to wear like their Apple Watch or their Garmin last night, because I know everybody got a lot of steps in going back and forth between the drinks and the food trucks. I'm gonna have a conversation with my coordinator over there about that. So a quick shout out. Favorite food or beverage from last night? Close second was the pizza with the cherry tomatoes, and I think it was goat cheese, right? It was really
I don't want to call anyone out or judge anyone, so we can all close our eyes and just hold our hands up if you want. But did anyone go back for like 2 churros? Anyone go back for like 3 or 4?
Looking at you, Darren Reed.
This is a judgment-free zone here.
Okay, did anybody not get the churro sundae? Like, is that next level or is that like the default, right? So good. Although I don't know really how you're supposed to eat it, so I was just kind of like shoving it in my face. Yeah, okay.
You're supposed to drink it. It's just...
All right. Awesome. I'm glad y'all had a good time, and I'm glad you're here for today's talks. Let's see, some quick housekeeping. If you haven't tried it already, I implore you to check out the Pour Over coffee stand. I know sometimes there's a little bit of a line, but it's probably worth it, especially if you like good coffee. Props to No So Familia for providing us with the coffee this year, and props to my adult children for actually making it. Just a quick reminder, and I saw that I already put a message in general chat, but please no flyers throughout the venue. I don't know, maybe other conferences, that's cool, but like I don't want trash in my venue, so please don't do that. And just a reminder, no drinks or food in the theater unless it's like the boxes of water. So appreciate that. And reminder tonight, and you'll see it up on the screen throughout the day, that we have the sponsor parties tonight. I think there's 4 of them, so that's pretty exciting. That should be a lot of fun. I think that's all I've got. Anybody have anything else that I should be aware of that we should call out? Otherwise, buckle up and have a fun day. And I'm going to hand it over to Pete.
Buckle up. Yeah, what kind of conference do you think this is? There's some graphs coming your way. Watch out. I actually just want to make a call out because yesterday in my Google Slides fueled rage, multiple people came up to me and said, I just got to ask, why did you keep calling Google Slides Google Sheets? And I don't know why, but it was just blinded by the rage of it all. But lucky for you, we have spent 10 minutes getting Google Sheets. Nope, I did it again. See, I can't figure it out. Google Slides working, so we don't have to deal with that. So I'd love to take it a big, if Jason will quit talking to our speaker. Are you done? Can we begin? Anyway, let's give a big round of applause to Paige.
Good morning, Monitorama. How we doing? Welcome to Portland. I'm Paige Cruz, Senior Developer Advocate at Chronosphere, and what I think I'm the youngest retired SRE in the business. We can talk about that. So, raise your hand. Do you see your first monitoring tool up on the slide here? There we go. All right, a good handful of you. Me too. Mine might not be yours. Mine was New Relic. And last question, raise your hand if you agree with the statement, chasing a single pane of glass is a fool's errand. Where are my people at? This talk is for you. Those of you not raising your hand, we will check in at the end. This talk is about how my experience in the biz has led me to really believe that there is no one-size-fits-all tool for observability that can flex to everybody's needs. And a little bit about how I'm shaped differently than some of my seasoned ops pals. I say I was a baby dev, born in a Docker container, shipped to an EC2 instance that was provisioned by Terraform. Like, I grew up in the middle of the cloud complexity, the microservices explosion, kind of walked into tech as all of that was blooming. And I've been on both sides of the vendor-client relationship, not once, not twice, but many times. So I think I'm bringing kind of a grounded view that's not just big monitoring's point of view. Started at New Relic as a vendor, then left New Relic to pop over, follow my friends at Envision, got the heck out of the design industry, ran back to monitoring with Lightstep, following my love of distributed tracing. I really thought tracing was going to be the signal to end everything else, and we would never look back. And here we are, like 6 years later, and it's still not mainstream. And I was like, you know what? I got to take a break. I'll pop over to the cannabis industry, see what's cooking there. And finally, come back to my love, monitoring and observability land at Chronosphere. So I know we can be a skeptical bunch, us technical folks, but I hope you can see I'm not coming from just a vendor's point of view. I have felt the pain of monitoring migrations, training people on new tools, butzing my way through different query languages. Oh my God, I know the pain that exists. And I'm here to talk about a specific type of pain, and that is chasing the single pane of glass, which for this talk, we will define as the one observability and monitoring tool to rule them all, the one that your company says, this is it, all eggs in this basket, this will provide the insights we need from our system, north, south, east, west, we'll never need another tool, this is it. But if you, like I, have embarked on a monitoring migration in the last few years, tried to increase the observability of your system, or just tried to train people on all the different telemetry formats that exist, you know this is a painful, painful journey. And I posit that this journey is not one that we all need to take. And in fact, it's not one that most of us should be taking. So let's get into sort of the arguments against chasing the single pane of glass. The first is tool sprawl. A lot of us feel, oh my God, there are too many tools, from Slack to my CI/CD system to source code. Like, we're clicking between so many windows and tabs, it can be very cognitively overwhelming. And I get that. However, everywhere I went after New Relic, of course, developers and operators use totally different tools. My developer friends were using the beautiful enterprise application monitoring suites, and my operator friends were all in Prometheus and Grafana dashboards, and I thought, this is the problem. This is what we need to solve. We need to consolidate. Everyone needs to be looking at the same data in the same tool. How else can we collaborate? And I thought, it's Prometheus I've got to kill. I've got to rip that out of my ops friends' hands. And I also, as I learned about Prometheus, I thought, oh my God, why would you run your own stack? Why does Prometheus let you choose your scrape interval? That is just asking for statistical nightmares. And I really, really believed that we needed to all converge on one tool. And then I grew up a little bit. I opened my ears and I listened to my ops friends, and they said, look, the ecosystem's here, the community's here. This is how we get visibility into the monstrosity that is Kubernetes. We've got dashboards out of the box. There's all these beautiful default metrics like, look, this is our bread and butter. Good luck taking it from our hands. And I thought, well, there's no way I'm getting the developers like all in on Prometheus. So like, what do we do about two different roles using two different systems ostensibly to monitor and observe the same system? Like, isn't this still a problem? What about tool sprawl? Is it okay that we have different roles using different tools? And I had to totally change my paradigm last year when I read Catchpoint's 2023 SRE report. And they just straight up asked, is tool sprawl a problem for your company? And the majority, 59.1% of respondents said, nope, not really, or only a tiny bit. I was like, what? They're wrong. The folks at Catchpoint are wrong, there's no way. And I looked closer and I read the paragraph that accompanied the chart, and it said, look, the question that you ask is not how many tools, but are those tools that you have providing value? And if the net sum of all the tools you have is making people productive and happy and they're able to do their jobs, you don't have a problem with tool sprawl. You're doing just fine. The problem is when you've got tools that are underutilized, that don't fit your needs, or maybe were for a previous architecture or something. So I really had to sit and meditate on this and be like, okay, it's really not the number of tools, even though that's what I feel like is the problem, because they brought the data. I had to change my mind there. And like, I get it. I don't think that multiple tools, like having 10 different tools, I'm not advocating for that. And in fact, while working at a company, when I was interviewing at Lightstep, they were like, hey, you're a customer of ours. How's tracing going? How do you like it? And that was my face, that whole question, or that whole conversation. I said, I am the monitoring maven, because spoiler, when you work at one monitoring company, forever, you are forever the expert no matter where you go. So I was in charge of switching vendors and consolidating, like I was knee deep in our company's monitoring stack, and had no idea that tracing, my true love, was already in part of our system. And so I had to really think, like, God, you may not be able to get, from a single individual contributor's point of view, you may not know all the tools that are running around your company or people stealthily installed somewhere. And what if we could embrace this idea of multiple monitoring and observability tools? Like, what if we could say, together, Dev, you look at what you need to at the app layer, Ops, you look at what you need to for the infra layer, for tools that are purpose-specific, built for those parts of the stack, and we could use those together and collaborate to understand our system health. What if? And so the second point, which I think is a real easy sell for this crowd, is that open source instrumentation is the way, the truth, the light. It is how we free ourselves from the walled garden of proprietary closed instrumentation, which makes it a huge pain to switch between vendors or even feel like you have control and agency over your own telemetry data. And we'll rewind a few years. Before OpenTelemetry kind of crashed onto the scene, if someone told me we were going to consolidate vendors, choose a new one, XYZ, I was like, great, I'm gonna be Sisyphus, I'm gonna be the one that's championing this, I'm gonna be like becoming a forensic accountant to understand why the bill spiked. Like, I just saw pain and misery going to the new thing versus just keeping the old thing running. And then I followed OpenTelemetry's beautiful birth into the observability scene. And not to be like that guy, but like I was into it when it was open tracing and open census. Like, I have been with OTel for a while. And I used to think the power of it was tracing. Tracing for you, tracing for you. Everybody gets a trace, we're all gonna be happy, bing, bang, bong, we're done. And then I kept seeing talks about this little OTel collector and how magical it was that instead of tying itself to just the OpenTelemetry OTLP format, they were like, we're gonna take your prom metrics. We're gonna take your ECS elastic formatted logs. We're not just OTel, we're gonna take in all signals. And I thought that is a powerful point of view. And I do a lot of talking at conferences, and this year alone, I've had 2 conference talks, one by Adobe, who talked about how they use the OTel collector to get, I'm not gonna say a single pane of glass, but to get one perspective on how much telemetry was getting sent, the volume of the different signals, and it gave them sort of a control plane over the data that they had. Why was this a big issue for them, or why was this a big benefit? Well, they acquire companies, and I don't know if you've ever tried to integrate an acquired company into your own stack, but people are quite opinionated about the tools they use, don't often want to switch them, and so the OTel collector was their way to manage that control and visibility while letting everybody bring their own stack and tools. The other one was Pluto TV, who said we were in the business, we were looking for new observability vendors. We popped in the OTel collector, and as soon as we wanted to do a head-to-head or apples-to-apples comparison, it was a config change to say send it to this destination, and this one. What used to be weeks of misery of trying to figure out how to route the different telemetry types at what time, or trying to like look at the build to like estimate how much the new tool was gonna be, and always knowing it was gonna be pretty wrong. The OTel collector kind of came in and said, look, let me be sort of the load balancer for your telemetry traffic. And I thought that is the power of OpenTelemetry. It's not just that traces are coming to the party, but the collector is giving you control over your own data. And there's a lot of benefits with the walled garden. Like, this is where I grew up. Install this agent, we do everything for you. Like I mentioned, my horror at the scrape intervals, like proprietary agents kind of did all that math for you and figured it out. But it made the cost of switching basically prohibitive. You were just locked in to that one system forever, no matter how much they wanted to charge you, no matter how much they were lagging in features and productivity suites, like, you're kind of stuck with them. But what if you joined the open source world and you had a community, you had an ecosystem, you had training you didn't have to build from scratch, documentation that you could just like import into whatever docs tool you use. Like, the power of open source instrumentation is also freeing us from having to learn every specific format. And I will just say, like, OpenTelemetry is doing very great with the documentation as well. I will give Prometheus its flowers. I have been reading through the docs, and I'm happy that there is so much for me to catch up on. And so when I think about open source instrumentation, it's not just the library that you're bringing in, right? At this point, it's not just like, oh, bring in statsd, bring in the OTel library, bring in whatever Prometheus library. It's about that whole, I think we're calling it the telemetry pipeline, the OLI pipeline. You can tell me later, but it's controlling that whole path of the data from instrumentation to emitting to you decide how you want to process, filter, drop, aggregate, and then send to different backends. That is all decisions that you should be making as the owners of this data, because they affect the data fidelity that you have. It affects the cost at the end of the day, something we all have to be conscious of. And so it's really about taking ownership over your data and freeing yourself from being tied to a specific vendor or a specific format. And the sad, sad truth, the bubble bursting moment for me leaving New Relic was that nobody thinks about monitoring as much as us, the people watching the live stream, hello, and the people watching this recording. I totally drank the Kool-Aid. I was like, everybody gets software's eating the world, monitoring and observability, that's the only way to understand, handle, scale these systems. Leadership knows it, directors know it, ICs know it, like, this is an area that is totally invested in at every org in the way that I expect. And like, no. When I got to my first SRE role, I realized as I talked to people and as I tried to audit what signals were we sending to where, that people on the whole treated monitoring and observability as an afterthought and as this sort of like annoying chore they had to do if like SRE team like yelled at them. Instead of like the thing that helps you on call and the thing that lets you spend more time with your kids, your friends, and your family. And I was like, whoa, the thing I've spent my whole career dedicated to is like a tiny blip on some engineer's consciousness. And when we talk about chasing the pain, the single pane of glass, moving and consolidating to one tool, there's a lot of people you have to educate along the way who may be very tied to their tool for specific reasons, or may just have other priorities. It may not be a top priority for your organization, team, or department to be chasing whatever new tool it is. And yeah, so you can have only so many priorities, and is consolidating just for the sake of getting the single pane of glass really going to give you the value for the massive labor that it takes, even with the OpenTelemetry collector letting you shift traffic around? Now you've got to think about, how do you get all your monitors over? How do you get your dashboards? Are the formats going to be the same? Like, how do I train everybody on this new UX and style of work? And oh yeah, you're going to have to listen to so many complaints about how this tool didn't do what the other tool did that was their favorite, and they're so upset even though they never filled out the form that you sent at the beginning of the process. Like, lots of opinions in this space. And so I'm not advocating for all of the tools, siloing your data, islands of knowledge, because today we've got a better way through. It is linking your telemetry together, even if it lives in different tools. We've got so many options now, from baggage, thank you to the W3C. It is not necessarily distributed tracing specific, but baggage is a way to pass context around between requests, to pass something like maybe a user ID that originates in one authentication service, all the way down to, I don't know, the database call or something else that is downstream or upstream. You can send data through maybe across like an API call to a third-party service. Like, we can get visibility across components that we weren't able to before without proprietary instrumentation. So if you haven't checked out W3C baggage, look at the spec, it's pretty awesome. The other thing is, basically all vendors have realized the power of linking at this point and give you a dashboard chart or widget that you can enter text in. What you can do with that, of course, is up to you and your org, but I recommend adding links to your logs that are pre-formatted queries scoped to the service of the dashboard that you're looking at. Dear God, please don't just link to your random, like, here's the log query bar that's empty. The power is in being able to hop from tool to tool, carrying the scoped context query like with you. Because, like we said before, different roles live in different tools. And I'm like not gonna spend 3 hours learning, the one I've avoided is Kibana query language, sorry, Elastic. But if I were investigating something, got to whatever formatted log query that I needed to for whatever component I was investigating, found an issue, boom, I can send that log link to somebody else and it jumpstarts their investigation so much faster. Didn't have to know that other tool, I was just following the breadcrumbs as they existed. The other part is logs. If you've got tracing, you can enrich your logs with the span ID or the trace ID, which means that you can go from looking at some funky log line over to a beautiful visualization of a trace waterfall, or looking at a histogram of aggregated traces. The power these days is in the relationship between our components in the system, the relationships that we can embed in between the different types of telemetry. So it doesn't matter what tool is your favorite or whatever, if you can follow the breadcrumbs to where you need to go, like that is what we're trying to do here as a whole, is understand our system, what went wrong and where, and not waste a bunch of time consolidating and taking on those big projects. So, what are like some goals? Like what, like we've got this problem, you probably have multiple tools already, you may not be convinced by the messaging so far, but like what are we ultimately trying to do here as an industry? Is the ability to go from, hey, my service alerted, my service is this car, I can only see what's straight ahead of me and maybe what's straight behind me. I know there's a problem because I'm waiting and my brake is on, but I can't see what it is. So to go from this view to like helicopter in the sky, I can see lots of requests, I can see the system more as a whole, I can see where that queuing started, and oh, if I'm looking at aggregated traces, maybe I click into a trace. Oh my God, a dog on the freeway. I mean, obviously our examples are different, but like the ability to go from services point of view to system point of view down into a specific service interaction, that ability to zoom in and out of the system, that is what you need your suite of monitoring and observability tools to provide for you. And if you are struggling with that process, or investigations take a long time, or you dread writing after incident reports because it is such a laborious task to investigate and just spit out a timeline of what happened, then you need to increase the observability of your system, and it doesn't mean shoehorning in to whatever tool you already have. You may want to bring in a new tool, but this is what we want to do. We want to let operators and developers zoom in, zoom out, and understand their system, no matter if they're looking at logs, traces, or metrics, because they can hop in between the different types. And for those who love a summary slide, here's how we live in a multi-tool world. Figure out if your tools are providing value. Please cut the ones that aren't. I don't know if you have access to like the MAUs and the DAOs, monthly active users, daily active users, but if like one team is using a tool, they should either teach everybody else how to use it, or you should figure out if it's really providing the value that you think. The next one is actually owning your telemetry. And that is owning what we're calling, I think, the pipeline from instrumentation and emitting, giving you the power to tune, drop, aggregate, filter, process, scrub out those like PII and the logs. All of that is business context configuration that you should be in control of. And the way to do that, open source instrumentation, Prometheus, Grafana, and friends, open telemetry. Then you want to link all your signals together with as helpful of links as you can provide with like pre-filled data, or if you've ever used Go links are awesome for quick log queries. And like ultimately embrace all of the signals, all of them, that you need to get the fidelity for you to be able to troubleshoot your system effectively. That is our goal. That is what this suite of tools should be doing for you. And I truly don't think there's one tool that's going to nail all of these things for a data scientist, for a DevOps infrastructure engineer, for an application developer, for a mobile developer. They're all really different components, and you're probably better off with purpose-specific tooling or really limited platforms that focus on doing a few things really well instead of trying to be everything to everyone. And so, with that, you can come see me if you want to talk about this talk. If you're like, nope, I've got the one tool to rule them all, and you want to make your case. If you're like, what's up with tracing and OTel? I'm curious. I'd like to sprinkle some of that in my system. Come find me for the rest of the day. I'll be upstairs at the Chronosphere booth, and I love, love, love talking about this stuff. So, with that, I will open the floor up if you've got questions.
Awesome. We've got some time for some questions. Any questions from the audience? Oh, we've got one right here.
You referenced GoLinks, and I wasn't sure what you meant.
Sorry?
I think you referenced GoLinks just a minute
Oh.
ago. I wasn't sure what you meant.
Yes, so GoLinks is like this URL hacking tool where you can type go / and then you can set up like logs and then tie logs to CloudWatch or Elastic, whatever you're using for your log backend. And then if that system allows you to like play with the query in the URL, what I would do is say go / log / service name / production and go right there. So as an SRE, I wasn't privy to all the intimate details of every application, didn't want to have to hunt it down. So having that kind of central place to just be like, what's up with the logs with this service? What's up with the logs with this environment? Was super helpful, especially if you've got multiple tools.
Awesome. Any other questions from the audience? Check up at the top. Anything? All right. Another big round of applause for Paige. All right, well, our next speaker is setting up. Just want to remind everyone that there is a channel called Lunch Party. If you're looking for a lunch buddy or are trying to find a place to go get lunch today, pop in there and drop a message. So there's a bunch of great places. And if you're trying to find, some ideas of where to go, it's a great place to ask as well. There's also some previous messages in there, I think, that Jason put in. We'll repost some of the lunch ideas. I'm going to still shout out to Little Shlomo for their brisket hummus. It's really quite amazing. Alrighty, let's kick it off with our next speaker, Ben Rockwood. Thank you.
Get this out. Thank you very much. I want to give a quick shout out to the staff, to everybody who's involved in this conference. This is an incredibly cool conference. It's really one that's been close and near and dear to my heart and the hearts of my staff for many years. And as somebody who's generally actually on the live stream, much love to everybody involved in keeping the live stream up, and much love to everybody who's out there on the live stream listening to it. It's great that we can all around the world participate in this super cool event, because all of you here are like the cool kids. So I'm normally at home like pining. So I'm super glad to be able to come here and share a little bit. I want to give like a really practical talk, and give everybody some useful things that they can sort of walk away with. I'm Ben Rockwood. I'm the VP of Engineering and Operations over at Mondu. Mondu is a super cool company that's in the we're in the policy as code and security space. So for many years, I started out at Sun, the Silicon Valley, and then I went to Joint, the first infrastructure as a service cloud, and then over to Chef and whatnot. And throughout my entire journey in the industry, one thing that's really bugged me is that we spend a lot of time setting up these complex infrastructures. We invest huge amounts of time in getting it just, every little nuance just right. And then we walk away. We walk away. And over the years, we came up with better and better tools for actually configuring and setting up and deploying our infrastructures. But once it's deployed out there, that's it. Like, we just sort of assume it's fine. And we know that that's inherently insufficient, because when we actually get woken up in the middle of the night, the first thing that pops into your head is, what changed? What changed? and a journey to try and figure out what is that thing that changed. And particularly when I take on security and compliance, I do compliance at a lot of the companies I've been with, and I always feel a little dirty when I sit there and tell my auditor that, you know, everything is configured the way that it's supposed to be. And then in the back of my head, my inner ops mantra is sitting there kind of going like, but is that what it's going to be in 5 minutes? Maybe, maybe not. What we're doing over at Mondu is we have 2 tools that we've open sourced, CNQuery and CNSpec. This was born by Dom and Chris, who did InSpec, which some of you may know. And it just sort of takes it to the next level. So we have the ability to query all of our infrastructure, cloud, SaaS, you name it. We can query what's out there. And then we can write assertions about what the state of that infrastructure is, which means I can now actually monitor change within my infrastructure. This is really important, especially for those times when you've like spent like a huge amount of time getting one little detail right. Like, you ever submitted a PR that was like a 1-line PR that you spent 6 hours getting to? Like, we've all done that, right? And you're just like hoping like nobody notices how long it took you to realize that you just needed to flip like 1 bit in a config file. But then the other part of you is like, dear Lord, that better never change. Otherwise I'm screwed. Because you're gonna have to go back through that learning journey, right? So anyway, we're doing some really, really cool stuff in the security vulnerability space. So we're a small staff, and we work really, really fast. And as a result, we need to sort of think on our feet. We're also a small company, and I'm super cheap. I don't like spending a huge amount of money on my tools, and so I want to share some of the patterns that I came up with, and this is one that I thought was kind of like totally obvious, but maybe not. And in particular, it's because it's a couple of very simple primitives here that we're going to talk about, GitHub Actions and Playwright, but you need to think about them in a certain sort of way. Given this like beautiful set, I mean, this is one of the things I love about this conference is that we get this beautiful set. I thought like I need a quote from A Midsummer's Night Dream, and man, this one just like nails it, right? This feels like my life. Take pains, be perfect. I mean, particularly in observability, I don't know about you guys, but that's what I feel like my mission in life is to work hard, take pains, with the intention of being perfect. Perfect for the company, perfect for our developers, perfect for our customers, and we don't always get there, but most of the time we get pretty close. I also think it's a little bit ironic that it comes from the bottom. So this is a quote from bottom. Anyway. A little story about how I got to this pattern with GitHub Actions and Playwright. Because shit happens. But more often, we don't actually say that shit happens. 3 a.m. we say, shit, that just happened. So here's a couple of things that happened that sort of led to this pattern. The first was in November when I looked at my GCP bill, because I also do all the financial stuff for operations. And I noticed that there was this like line item that I hadn't seen before, and it was for uptime monitoring. I never noticed that before. Like, why is that number like really large? Turns out that GCP, so we do most everything we do on GCP. In GCP, they had really nice uptime monitoring. You can go and create a probe, and you could just like almost any of this, Pingdom or any of the other solutions out there, right? You can specify a URL, any parameters that you want to. You can choose what region you go into and how often you do it. And here's a neat thing is they didn't charge for it. So I was like, yes, please. I will monitor 50 different URLs every 5 minutes from, yes, let's do all the regions in the world. Why not? Zero cost. It's fantastic. Apparently it's somebody at Google decided this maybe isn't like the smartest idea, and they should actually like charge when you do more than some number that I don't recall. So all of a sudden I start getting charged for this, and I had to suddenly realize just how spoiled I was that I was getting all these for free. So I had to deal with that. So I started looking around, okay, if I'm gonna pay for this thing, do I wanna continue to use GCP or do I wanna go look at something else? So I go and look at all the players. Pingdom was first of mine, used that lots of other places, but then after that whole SolarWinds thing, it just feels a little unsavory to do anything with those guys. I mean, it happens, but still, like, it didn't feel quite right. There's a lot of other great solutions out there, but I sort of really noticed like it's just expensive, just no matter what you do. And the combinatorial math like kind of like gets really high, right? It's when you first look at that like number and you're like, hey, I'm doing like 1.2 million checks per month, and you're like, that seems like a lot. Then you start breaking it down, regions, URLs. And, okay, yeah, no, actually I do, right? If I'm monitoring every 5-10 minutes, yeah, that adds up real quick. So of the available solutions out there, it was really now, okay, if I'm going to pay for it, I better get my money for it. And was not really blown away with a lot of the choices that I had out there. It all felt a little too basic. So not long after this, I ran into what we'll call the Firebase incident. So like a lot of you, I got all these great dashboards. I got all this great telemetry coming out of my system. I know the latencies. I know all I'm looking at everything, right? And I've got a couple extra monitors because, I want to actually live in a NOC, but I don't. So I've got a couple extra monitors in my office. So I'm looking at everything going on, and boy, the site's just humming along. Everything's going great. And I got a report that users can't log in. Turned out we use Firebase for auth, and there was an incident that was going on in Google with Firebase. Now, it didn't last very long. But here I am looking at this dashboard that tells me everything is fine, right? I'm looking at all my data, everything's great, except users can't log into the friggin' system. Ouch. Not perfect, right? Not perfect. So we need to go a little bit further than just, are the URLs responding and looking at latency and all these sort of normal things we're looking at out of the system. Because if new users can't log back in, that's a problem. So I need to do some comprehensive testing. And what happens when you do testing a lot? Testing just turns into monitoring, right? So a little bit about the architecture that I was dealing with here. So at Mondu, we have two open source client scanners, CNQuery and CNSpec. So you have two binaries. Data is transmitted from those when you do a scan up to GraphQL API. We have one in the US, one in the EU. We've got a simple UI, SPA app that sits on the front end that interacts with the GraphQL API. And our iteration of release is very high. So we do at least one release every week. Usually it's 4, 5, or 6. We release very, very quick, the front end and the back end and the client. So it's a lot of release and a lot of moving parts. And at the rate that we're moving, it's very possible that problems can come up. So what do I want to test? What I'd like to do to test here is I want to spin up 2 Docker containers, one per region, one for each region. I want to install the latest CNSpec client. It's dependent upon the code base for CNQuery, so I kind of get that for free. I want to execute a scan. I want to validate that there was a successful execution of it. So cool, client's working, and I can download and grab it. Now I want to log into the web console for each region. I want to navigate to the results, verify positive results, and then delete the assets that I just created in the system and then log out. So I want to be able to see the whole process from sort of end to end that anybody would go through as they were using the product. And so if I can do that, what I've verified is that the installation procedures are working, the client is available on the release site, because right, we've got to host all that stuff, and that's one of my concerns. That scans are completing successfully, so all the profiles are working, that the API is accepting results, so the server and the database are good on the back end. The client is being served, so we can log into it. Authentication services are functioning. Console elements are functioning properly because I'm navigating around the site, and both regions are healthy and performant. So this gives me a really nice sort of end-to-end sort of testing of our entire environment. And this is sort of what I need to complement all the other sort of observability that I've got going on. So what I decided to implement was a pattern based on GitHub Actions and Playwright. And naming is super important. Now, a lot of people think that naming is hard. I don't think it's hard, but it's just like, you just need to get it right, right? And I was trying to think of like a good, clever name for this, and I was thinking like, well, it's kind of working out, sort of exercising, kind of need like that like 80s Jane Fonda sort of like thing. And then like, it occurred to me like Richard Simmons, like, yeah, Richard Simmons is good. And then I found this picture. Not today, Satan, not today. I was like, that's exactly it. That's the feeling. that I've got. So we're gonna go with that. So it became Simmons. We exercise the site every 30 minutes. We send results out of Simmons via notifications to Discord, because like I said, we're cheap, so we don't use Slack. We're with the cool kids who use Discord. And the great thing about this is the cost is zero. Nada. So, let's talk about the two elements that make this up. Everyone's, I'm sure, heard of GitHub Actions, but there are a number of people who actually think of GitHub Actions as like a CI/CD pipeline. You're not wrong, but it sort of misses a couple of interesting properties of GitHub Actions. In GitHub repositories, we can create actions, right? Those are workflows that are consisting of jobs and steps. And you can create as many of these as you like. So as opposed to a lot of the CI/CD solutions where you have like sort of like one master sort of config, and everything is sort of tied off of one master config based on, you know, different sort of branches of your pipeline or whatnot, these are completely decoupled. There is no implicit relationship between them. So I can do any number of things that I want to do, and they have no dependency upon each other. They can execute in response to events. So, you know, your normal ones, push, pull request, merge, right? Those are all pretty standard. You can call them manually via workflow call. You can remotely invoke them via repository dispatch. That's one thing that we've actually used in our release pipeline. Somehow I ended up becoming release engineering as well. I actually broke all the different sort of builders for all of our different client versions into different repositories, and then have one master repository that calls each of them to invoke the function. So I essentially have this like microservices oriented like release pipeline, which is super cool, except the developers are just like, I showed them a graph of how it works, and they were just like, no. But it's fun. You can call via webhooks, you can watch, and you can use almost any manipulation of a repository to actually trigger an event. But also, super interestingly, you can use a scheduled event, which can take a cron, which means I can do anything I want on a schedule. Now, I'm old school, and I kind of pine for the days when we had the admin server, right? You had that like one server in the corner, then you could just like put arbitrary cron jobs in it to just go and do sort of different functions. And I know, you're not supposed to do that because then it's a single point of failure, and then anything happens, and then it turns out you put way too much on it, and then everyone's like, don't touch that machine, right? Because like the post-it note on it, this is like, don't touch. I know, but it was kind of cool. Now I have this, right? I can actually do a lot of these sort of administrative tasks using actions, which I really like. These workflows can be run on hosted or private runners. They're built by the minute. You've got Windows, Mac, and Linux runners available. They're inherently source controlled, right? So you kind of get that for free because it's in a Git repository. But here's the interesting sort of thing. If you are in a public repository, hosted runner minutes are free. Also, if you use private runners, you don't have to pay for those minutes. Now this is super interesting because it's actually a really cool thing on GitHub, Microsoft's part. They're kind of really encouraging you to get out there and make your stuff public, right? So it poses a really interesting question. If I'm going to run this thing in GitHub Actions, it's going to consume a lot of minutes. Do I need to pay for those? Well, if I make it public, I don't have to pay for those minutes. And then you suddenly say, does my monitoring actually need to be private? Does it? Not really. So if I can make that public, I can now share with all of you, with the community, right? My average customer is not going to care about this stuff. People in the observability community, you guys might want to see. I would love to see how you guys are doing it, right? Why do we need to put this stuff behind closed doors? So the first thing here is the paradigm shift is Actions is an amazing automation platform, and you should think of it as an automation platform. If you've thought of it purely as a CI/CD pipeline, you're sort of losing out on a lot of interesting possibilities. And as it turns out, that's actually how Actions started life. Okay, so here's an example of an actual action, if you haven't used them. We've got a name. We've got on that describes any number of events. Here I've got two events that we're associating with it. One is workflow dispatch, which is like manual, invocation, and then the schedule. And so I'm running at 15 and 45 of every hour, right? I've got a job. Here I have asset scan as my job. I give it a name, give it a timeout, tell it where I want it to run. In this case, Ubuntu latest means an Ubuntu hosted runner. And then I've got a number of steps. And those steps can be, like the first one here, uses. This is where we're using a reusable action that goes and checks out the repository, v3. And then any number of sort of additional steps. So here I'm using a secret to pull a configuration that's been base64 encoded. I drop that into a file on my runner. Then I go ahead and pull my Modu client Docker container, and then actually perform a scan, right? Boom, easy. At the end of this, I can put notifications on there. So here I'm actually, like I said, we're using Discord. So I actually am using an action here that has a conditional on it, if failure. So if at any point in the workflow that we fail, we're going to invoke this. And in here, I'm just going to go ahead and send a message. Again, I've got a secret here, which is a webhook. And that's going to go ahead and send a message off that says, oops, scan failed, right? Okay. So with that action, I have the ability to sort of do the first part of the testing that I want to do, which is I want to go grab my client, test it, pull it down, do the scan, send data in. Okay, great. Now I know that all that is working. Now I want to go and actually look at all the results to sort of verify that everything sort of got to where it's supposed to be. And for that, I'm using Playwright. Playwright is a really amazing open source end-to-end web app testing framework from Microsoft. They did a really brilliant job of this. And as an ex-Sun guy, like I feel kind of weird, kind of loving on Microsoft so much. Like, it doesn't come natural. It really doesn't. But I got to say, these guys are doing great stuff. Like, just mad props to Microsoft and the way that they've gone from the evil empire to, you know, the benevolent friends to all of us. They've done some great work. Playwright is very similar to Selenium, if anyone's played with Selenium. Selenium's been around for a very long time, very cool tool. It's evolved a lot over the years. But Playwright had the advantage of sort of coming on the tails of it and sort of learning all the lessons, right? All these things that Selenium sort of did sort of poorly, Playwright was able to take advantage of that experience and get it right. And so they really got it beautifully right. You can write tests in JavaScript, TypeScript, Python, .NET, or Java, so sort of no excuse for it not having support for the language that you want. You can execute tests on Linux, Windows, or Mac OS. It supports Chromium, WebKit, and Firefox, so you've got the gamut of backed browsers. You can run headed or headless, and you can record video output, screenshots, and it can create reports. So you can get really detailed data out of each of these runs. And most importantly, it's got a really amazing test code generator. So the hard part of getting started with a lot of these is like, okay, how am I going to sit down and like write all these sort of test scenarios and whatnot? Playwright makes it super, super easy. So practically the way this looks is, so this is the JavaScript use case. In this case, I'm going to use yarn, create Playwright. That goes and actually creates a repository, or a directory for me. Asks me a couple of different questions. It will actually even create a base GitHub action for you directly in it. Does all the sort of basic setup. Once you've got that, you can go in there and use Playwright CodeGen and give it a URL. In this case, you know, console.modu.com. But you give it your site. Now it pops open a browser and we can start clicking around. Once you've got that basic test, you can go and modify it to taste. So you're generally going to go and modify it with sort of specs and whatnot. That's the test element. And then when you actually want to invoke it, Playwright test. And the test goes off and runs. Couldn't be easier. And so this is the beauty is their CodeGen. So in this case, you see on the left, I've got a browser that has popped open for me. In the top hand corner, you can see npx Playwright CodeGen in a URL. It pops open a browser, right, that I specified. I can now click around and do whatever I want to do there. And as I'm going in my right-hand window here, it's actually creating each of the steps as I go, which is awesome. You can log in. You can use SAML SSO, you can record tokens, you can do all kinds of wonderful things. And you even have up there in the top right-hand corner of the interface, the target test runner. If you're using Python, you can specify that you want Python, it will generate Python code for you, right? Whichever language you want to use, really easy to generate that. And now we've got our tests. So now we just have to create a new job in GitHub Actions that's going to install Playwright. Then it's going to go invoke the tests on it. And at the end of the run, I actually add this step here. So this is a reusable action that uploads artifacts to GitHub. Again, we use a conditional if failure. So if we fail anywhere inside that job, it's going to go ahead and invoke this. And we can go and pull its results. So we can actually create that screen recordings, create those screenshots, and a full report. It'll be dropped into that results directory. And now I go ahead and upload that on failure, and we retain it for 14 days. This is one of the things you do want to be careful about, the amount of storage that you're consuming on the service with these. 14 days is long enough for me to sort of be able to go back and correlate. And if it fails, then I end up getting this Playwright report here at the bottom of my failed action run. So I can go and investigate exactly what happened. I can go replay the video and see exactly where in the flow things broke down. So you can check this out for yourself. Like I said, it's open. I think it's probably going a little too far to say it's open source. It's like not that much source. But it's open. You can go look at it. GitHub.com/MondoHQ Simmons. You can see all the runs there. You can see the runs that fail. One of the things I would advise as you do this is you will suddenly notice that like IDs and different sort of hooks within your UI, you really want to make sure those are stable because you're using those to actually direct Playwright through each of the sort of steps. So, you know, it's always funny when I see like, you know, an instant double failure, the first question is like the developers move something. So we've actually made some changes in the way that the UI team works so that they're updating the Playwright tests as they go. So they're using Playwright on their own in UI for tests prior to release. But then I actually have them make sure that they sort of keep stable hooks so that it doesn't break our tests. I want to throw out, if you've played with Playwright or you've ever looked at Playwright before, you can't help but run into these guys, Checkly. Checkly is a super cool company. They're doing some great stuff. I kind of bagged on the solutions that are out there, but Checkly's great. Pricing is reasonable, but they're also doing really great things for the Playwright community. And so I really want to sort of call out to them a big shout out to them because they're doing really, really great stuff. If you don't want to sort of do it this way and you want a hosted service, definitely go check out Checkly. The only thing you're going to lose there is that flexibility of sort of that front part of I want to do any arbitrary thing I want to do, and then I'm going to go run Playwright. In that case, you know, it's hosted on them. So very, very cool solution. Perfect. Don't go. So hopefully this helps you out. So anybody who's not doing end-to-end testing, you have no excuse now. Like you can go build it this afternoon, super easy. Everyone can be on the same page. I hope this helps you out. I hope it challenges the way you think maybe about GitHub Actions and you know can build some interesting, cool things. So thank you very much.
Wow, that was perfect timing. I just want to say, like, inspirationally, Ben is like, this is hair goals, right? Mine's very straight. And I'm like, look at that volume. It's truly amazing. Yeah. Well, I just gotta have dreams, right?
Yeah.
Any questions for Ben from the audience here?
Or topics you want me to rant about. Apparently there was not, I heard yesterday there weren't enough hot takes. So I'm perfectly happy to go and just start dishing on things. This is another fun tradition from Sun Microsystems is, you know, we're good at dishing on stuff.
Yeah. Oh, we have one. Here you go.
You're saying you ended up on the 30-minute eval rate, knowing it was free. Is that kind of limit?
No, I could run it every 5 minutes if I wanted to. 30 minutes just sort of felt right for our use case. I could run it much more aggressively if I wanted to. I think a total run from beginning to end is just under 3 minutes. Actually, if you look back at the slide, it's about like 3 minutes, I think, to actually run the full thing. So yeah, 30 minutes just felt right. Yeah.
At some point they will start trouble.
Sorry?
At some point the cup actions will start trouble. You run to frequently automated.
It will stop talking?
Oh, like it'll time out after. Is that what you're saying? It'll time out eventually.
Yeah, I have not hit a point at which I've gotten throttled by GitHub. Yeah, I mean, when I have experienced, there's plenty of times where if I get too aggressive with the GitHub API, I get throttled out, rate limited on the API. That happens constantly, and it's annoying. Like, dear Lord, will they please, raise that limit? I don't know how busy their back end is, but it's ridiculously low. But I have not actually ever gotten throttled with regards to executions of pipelines.
Another problem, sometimes it breaks. You have to wait.
It's been remarkably stable for me.
No.
Yeah, here.
Do you have a sense of cost? Like if you were to run this using GitHub's infrastructure, are you running it on private runners?
No, I'm running it on GitHub's infrastructure, but because it's public, the cost is zero. That's the key. Because it's public, there's no cost. Like I said, this is I think a really nice thing that Microsoft and GitHub are doing is that they are encouraging people to sort of keep things open. And so we as a company have been, wherever possible, we're opening things up, right? There's all kinds of things in our release pipeline or whatnot that I'm like, do I really need to hide the way that I'm building a Mac package? No, not really. In fact, I'll go so far as to say that when I was trying to figure out the right way to build a Mac package, there were very few good examples out there. So I'm like, at least I can sort of contribute something back too. So it's sort of a win-win. But the thing is, admittedly, to the point that was made yesterday, things are changing in this economy with interest rates on the rise and whatnot, and there's a lot of scrutiny on startups to make money, right? It's not just about doing whatever it takes in order to gain customers. And so, yeah, it's very possible that, next week, GitHub comes out and says, oh, that's the end, no more. You got to pay for minutes, whether it's public or private. In which case, sort of the party's over. But for now, help yourself.
What it would cost you if you had to pay for it?
Yeah, I don't want to pull the number out of my head right now because I know it will be wrong. But yeah, you can go and you can look at the cost. I do regular pivot charts. This is one of the things I look at every month is in our GitHub builds. I'm looking at all the minutes accumulated and doing the cost factor and whatnot. And I mean I think it's reasonable. It's reasonable, but I'll also tell you that if you want to go the private runner route, dear Lord, please, don't go get a VM. Ugh. Doing this on a VM. VMs are ridiculously expensive, right? It's a conspiracy to make us run everything on containers because holy shit, are VMs fucking expensive. That's how cheap I am. It's I think the VMs are incredibly expensive. $80 a month? No. You can go to Herzl or some of the other server providers, and an auction, you can get a really beefy, physical piece of hardware for $40 a month, right? So that's all of our private runners are Herzl robots. They're server auction machines with 128 gigs of RAM and a couple terabyte of NVMe, and they cost $40 a month.
I think there was another question over on the side. Yeah.
I think you alluded to the 3-minute test. It takes 3 minutes to do a test. Do you have any advice for heavy JavaScript sites with lots of third-party integrations where when you get one false alarm on a 3-minute test, if it fails for some oddball reason, you start ignoring failures. You don't see alarms for a very long time. Can you speak to that?
Alert fatigue is real. Yeah, for sure. I felt a little stimulated. One of the talks we had yesterday where we were talking about alert fatigue was there's that sense of I just want to know what's going on, so I don't mind the alert failing all the time. I've fallen into that a lot. A lot. I'm one of those people. So there's two ways you go about that. One is just that if there is this intermittent behavior, you should definitely be aware of it, right? The other is it gives you the opportunity to sit down and take the time and figure out where are those things happening, right? And that's where the discipline comes in. Is if we're timing out all the time, look, we need to slow down as an engineering organization. We need to figure out why, because it shouldn't be happening. It's intermittent behavior, like what's going on there. And that can be the really hard thing. And this is, I mean, the bane of our life, right, of observability is that you learn things. And then you go back to, you know, the stakeholders and you're like, great, now I've learned this thing, we should do something. And they're like, not in the roadmap, right? And you're like, I know, but we should do it, right? And then you end up getting these weird places where they're like, could you just not monitor that so that we don't have to like think about that problem? Because nobody was complaining before you showed us this data, right? Oops.
So maybe to ask different, you test every 30 minutes. The first time it fails, do you skip it? Or are you actually looking at that each time it fails?
I am not looking at it every time it fails. And there are intermittent failures that happen. You know, admittedly, if you go and look, you'll see that there are intermittent random failures that occur. I make a point, like usually once a week, I'll sit down and like go back through all those reports because I'm holding them for 14 days, and I'll look at them, right? And yeah, I get like a sense that there are some that fail, and like I don't worry about all that much. If I get a double failure though, because I'm doing 2 regions, right? So if I see a failure in the U.S. and the EU simultaneous, then I know something's not right. That's not transient.
So you have something to tell you when both fail? Or is it more you're reacting?
Each of them will message out. So actually, this is why you'll notice in the oh, I didn't include that. But when I send the message into Discord with the failure, the region that failed is a variable, right? So I can see individual, you know, failures there. And they're definitely, just like any sort of monitoring system, you kind of like get a sense for it over time. Particularly if you see like 2 failures in a row, something's very wrong.
I think there might have been a question over on this side. Didn't want to miss it. Anything? All right, last call. Any other questions? Yeah, one right here.
When you run a playwright status test, and like I think you mentioned in generate video archives, are those also saved? Like someone you get a console for that?
Yeah, they're uploaded and they're saved with the action.
That's part of the action.
Yeah, it's part of the action. In fact, so if you go and you look at my repository, you can go look through all the actions, and any of them that have failed, click on that, and at the bottom of the page, the results page, you'll actually see the output. So the output, you can actually configure Playwright to actually give like GitHub action, you know, nice error messages, so it actually gets picked up as annotations on it, so you can see it pretty quick. But then when you see the artifact down at the bottom, so any of you guys like go and like download like the video recordings and the reports and see exactly where it went. If you find anything, please let me know. I won't like pay you consulting hours, but like I'll definitely be grateful. You'd be like, you know. Or salty. I mean, the thing is when we give each other advice, it normally starts off with, "Hey, dumbass." "Hey, did you notice, you idiot?" So.
Awesome. Thank you so much. Another big round of applause for Ben.
A couple quick housekeeping notes. One, is Lerna in the audience? Anybody? Okay, if anybody sees Lerna, please have her come see us. 2 is, if you haven't already gotten your socks, please go see the sock table. Be prepared to give up half of your ticket. We do a raffle at the end of the event that uses those tickets, so if you want to be included in that, please make sure to use your ticket to get your socks. I think probably after lunch today, we'll probably just start giving away extra socks. So make sure you get your socks. Anything else?
We will be back at going to 11 o'clock. I can't unlock my phone. We will be back at 11 o'clock. I think there are some snacks at this break. Snacks in the back. Coffee. Help yourself. Get some coffee. And we'll see you in 30 minutes. Welcome back, everyone. Hopefully you're well caffeinated. There were snacks out there, right? What was the snack? I'm kind of hungry. Oh yeah, sounds good. No, they're hopefully like nut free. I'm not a nut free person, but I'm like kind of offended when there's nuts and brownies. Like they just don't belong there. Like hunks of chocolate, yes, but a nut in there just throws the whole thing away. Yeah, awesome. That's great to hear. Well, fantastic. I'm really excited for this talk because when I think about monitoring and observability, my background is not in the math at all. And I usually struggle and have to do a lot of research, and it's an area that I am always continually learning. Today we're going to learn about just enough math, right? Which is perfect because I was a communications major in college and specifically did not take any math. So let's give a big round of applause for Learn On.
Hi everyone. So this is Have No Fear, and that is the opposite feeling that I'm feeling right now. And it's just the math you need to know for monitoring. So in monitoring, we have these mathematical concepts. When we're visualizing the data, we may be using log scale, for example. So we're going to look at that. We also have a ton of data, and we want to summarize it. Typically, we use the center, like median, mean, mode, spread of the data, and we may also be looking at percentiles using relative standing. So we're going to be looking at those things. So if you're interested, stick around. The very first thing is logarithms, and obviously for that, we're going to use XKCD. So this is the XKCD on height, and this XKCD contains the entire contents of the universe. I know it looks tiny up there, but that's what it contains. The objects and the sizes of those objects, they are not to scale, but what's to scale here is the height of where those objects are placed. And this is accurate on a log scale. So first of all, we're going to start at the top of the observable universe, and that is hanging up on top of your heads for 46 billion light years up there. That is 435 yottameters, which is 435 times 10 to the 24 meters. And by the way, I just want to make a note that there's a cat that is being dropped from the top, and we just want to see if it's going to land on its feet. I'm going to root for the cat, and I think it's going to land on its feet. So this is the height that we're covering in this log scale. It is a ginormous height. It is the biggest height you can cover. And that is the point of log scale. So we want to display a very wide range of values in a compact way. We're going to go down to the grass on Earth, which is what we have on the stage, so very convenient. We are going to look at the Great Pyramid and how it's shown in a log scale. We're also going to look at the Eiffel Tower. So the Great Pyramid in a linear scale is obviously a pyramid. But in a log scale, what happens is from top to bottom, as you go down to the bottom of the log scale, on the y-axis, what's going to happen is those values are going to get stretched up. So what ends up happening to the Great Pyramid that it looks like a bullet instead of a pyramid at the bottom. And if you think about it, on a log scale, you have powers of 10 on the y-axis, right? You have 1 to 10, 10 to 100, 100 to 1,000. So you're covering less and less values towards the bottom. That's why you have more room to stretch them up like that. The Eiffel Tower, on its sides, it's inwardly curved, and that approximates an exponential curve. So on a log scale, it's correctly drawn in this comic. Exponential curves are represented as straight lines. So that's what happens to Eiffel Tower's sides. Next, we're going to look at the different heights here. So 1 light year, it is an order of magnitude 10 to the 15 meters. 1,000 light years is at 10 to the 18 meters. Million light years, 10 to the 21. And billion light years is 10 to the 24. So the distances in between is actually a multiplication by 1,000. And that is the point that in log scale, instead of adding the same quantity to get to the next level, we are multiplying by the same quantity. As I'm speaking, your ears are perceiving the sound at a log scale. And this is so your ears don't explode, because you need to be able to hear whisper, mouse squeaking, but also you need to be able to hear jet engines flying. So it's a very wide range that your ear needs to accommodate for, and that is why normal conversation that you may be having in a hallways that is at 60 decibel, and vacuum cleaner is at 70 decibel, so the difference in between is perceived by your ear as 2 times as loud. And Gustav is the gnome who came up with that. Now in monitoring, we may have disk usage or memory usage type of data series like this. And as you can see on top, we see the used data series that is clearly visible. And then the free and cache usage is not very visible, is actually delegated to the bottom pixels in this graph. When we redraw this in a log scale, and this is using log base 32, it actually has room to grow. Just like the Great Pyramid, it got stretched. So you can actually see the free and used data series down there. I want to talk a little bit about origins of logarithm because I didn't know about this and I think it's phenomenal. So in late 16th century, folks didn't have Gen AI and ChatGPT. So they just had to make do with observational astronomy and celestial navigation of ships as the top scientific fields that they work on. And these fields required large multiplications of large numbers, and mathematicians had to help speed up these large multiplications of large numbers. So what ends up happening for mathematicians is that their lives were miserable because they had to do tedious calculations. These calculations were error-prone, and they suffered. They couldn't go to the pub and tell physicists that math is better than physics. So John Napier came up with logarithms, and this was in early 1600s. And he called it the wonderful laws of logarithms. And what logarithms do for us is that they turn multiplications into additions. So instead of multiplying ginormous numbers, we are going to be adding ginormous numbers, which is an easier problem to solve. And they also turn divisions into subtractions. And you can do all this with the help of a log table at the time. So this is early 1600s. Henry Briggs came up with the common logarithm, which is log base 10 log table. Of course, today we use computers for that. Now I'm going to move on to another reason why we may be using logarithmic scale, and that is to display relative change instead of absolute quantity of change. And I think we understand this best when we talk about losing money. So if you bought stock at $20, and if you lost $10, that is a 50% loss. But if you bought stock at $100 and you lost $10, that is a 10% loss. So it doesn't really matter that you lost $10. What matters is the relative quantity or proportion of what you lost. So this talk came with a time machine that wasn't, in the program, wasn't told to you, but we're going to take that time machine and we're going to go back to 1930 October. And we're going to take a look at the Dow Industrial Average at the time. As you can see, it's within the hundreds in value. And in 1929 October, you are seeing a dip. So this dip is what's marking the beginning of Great Depression, and it is called the Wall Street crash. We're going to take that time machine and we're going to actually go to 2021. And we're going to now visualize 100 years worth of the Dow. As you can see now, the Dow is actually going into the 30,000s range. And the dip that we saw just a little earlier now looks like a happy little bump. Now, we know that our graph is not telling us the real picture. And Dorothea Lange will tell you so. She was the very first documentary photographer before that term was coined. And Dorothea documented images of migrant workers who were moving to California in the hopes of finding work to feed their families. And this is the image, the photo of Florence Owen Thompson. And in addition to the two children next to her, she's actually holding a baby, which is something I didn't notice until very recently. So our graph is actually hiding this real picture from us. So how can we get back this important information? On the left side, we have the linear scale graph. On the right side, we have the log scale graph. And as you can see, obviously, in the log scale graph, the y-axis is going as the powers of 10, as we expect. So in the linear scale graph, we have the values between 0 and 10,000 on the left-hand side. And on the log scale graph, we have more room to fit those values. So they're actually going to look stretched up like the Great Pyramid. And that means we can see the rates of change clearly. So the Great Depression, the beginning of it, is actually back to us, even though we're now visualizing 100 years worth of data. And we can also see the 2007-8 financial crisis, which some of us had to live through. Now, the final one that I'm going to go over for log scale is it's easier to identify exponential growth in a logarithmic scale. So for that, we're going to look at the confirmed COVID-19 cases from the beginning of the pandemic is where I want to focus on. And in the beginning of the pandemic, we were asking questions like how quickly this thing is spreading, what's the infection rate? Because we wanted to make decisions based on that, like are we going to be going to a lockdown mode? Are we going to be working from home forever? For introverts, working from home forever is not a bad thing. Speaking from experience. In log scale though, so in linear scale, you couldn't really tell if that was an exponential growth. And in log scale, you can see the spike, but I really wanted to see the exponential curve, so I basically plotted it. For the first 2 weeks of data of confirmed COVID cases, actually in linear scale, you see the exponential curve, and on logarithmic scale, you see the straight line, so it looks like a beautiful exponential growth that is clearly visible in log scale. And this is a latency graph that is in logarithmic scale from the SRE book. And it is actually displaying data over a very wide range of values. So it is going from 10 to the negative 3 seconds, so that's like 1 millisecond all the way to 100 seconds. And you can clearly see the rates of change here. Now we're going to shift gears and look at how do we describe the data. And one of the very first things that we look at when describing the data is to look at the center of data. And for that, I think all of us know how to take an average, so this is pretty primal. But one of the things that we think about when taking the average, and an analogy for an average is that it is the balance point by the weight of the data points. So if you had norms and you put them on a seesaw, you wanted to balance that seesaw based on the weight of those norms. And these norms, they don't just play, but they also work. So they have salaries. So we're going to take the average of their salaries. So 400,000 over 4, which is the count of the norms, and that is the mean at 100,000 right now. Next, these norms are going to make friends with the world's richest norm, who ends up, who is also swimming in gold. So what ends up happening now, if you add this data to the sum, earlier sum, and divide it by the new count, then you get this 1.4 billion as the mean. So the 4 norms, with the humble salaries, now are represented by this new mean, which is 1.4 billion. The norms are not happy because this is not a good representation of the average norm's salary. And if you start looking into this area in statistics, there's this very famous quote that comes up again and again. And it goes like this. Then there is the man who drowned crossing a stream with an average depth of 6 inches. And I can guarantee you this man was not a gnome. So averages hide the outliers, and outliers skew averages. So averages are not enough to describe the center of the data. So we need something more. So we're going to look at the median. And median, we can think of it as balancing on the seesaw by the number of data points on each side. So first, we have to sort the data. And after we sort the data, you can see the outlier is now going to be where it should be, which is on the edges. Then we chop the data in the middle with a guillotine, and that is going to be the median. Now, if we have even number of data, then we can just average out the middle 2 points. NFL players' salaries is a good example of this. In the newspapers, we typically see of the mean, the average salary, which is 2 million. This is old data from 2018. But this mean is heavily skewed by awesome quarterback salaries like Patrick Mahomes. The median salary, on the other hand, is more representative of the average player's salary. So that's 860,000, and that is more like, for example, a kicker's salary. So when you're negotiating your salaries, you know, don't just look at the average, but also look at the median. And mode, so mode is the value that appears the most often in a data set. It can happen that there's multiple modes. It can happen that there's no mode. There is really good blog post by Brendan Gregg on multimodal data. I would recommend that you take a look at that, but I'm not gonna go into too detail into mode here. So this is from the Elasticsearch blog, and let's say that you have a public-facing website and you want to make sure that your known visitors are having a good response time. So one of the initial statistics that you may look for is the mean and median latency for that. And here, the red and blue lines are the mean and median latency plots, and they are hovering around 50 milliseconds, sometimes peaking at 75. So things are looking pretty happy, rosy in mean and median level, but that's not enough. We are going to be looking at percentiles as well. So that is, the green line is the percentile line. This is from Grafana blog post, and it is talking about over-provisioning versus under-provisioning your Kubernetes resources and correlating the average CPU usage to max usage to understand that. If you're over-provisioning, then you're paying way too much, more than you need. And if you're under-provisioning, then you may have performance degradation. So to be able to basically ensure that you're not over-provisioning or under-provisioning, then you can use this type of graphs where you're correlating average to max CPU usage, for example. Another thing that we care about is the spread in data, and how do we measure that? So for this, the analogy is thinking about your data, and if you were to hold all your data points in your hands, would they be concentrated in one spot like a golf ball, or would they be dispersed all over the place like a ginormous cotton candy balancing on top of, a human's head in a fair? So for measuring the spread, there are different ways to do it. If you were to do the max minus min, meaning using range, that means that you're being affected by the outliers. Another way to do it is using interquartile range, which means that you're taking the middle 50 of your data. It's like taking the heart of the data. This is not going to be affected by the outliers. And another way is using standard deviation, so I'm going to look into that. Now, all of you in the room, you are a shoe manufacturer, and I am going to give you just one data point. The average adult female shoe size is 8.5. So that data alone is not going to help you to be able to decide how many shoe of each size to produce. So for that, you needed to know the distribution. And that is how standard deviation helps us. It helps us in understanding how concentrated the values, data points are around the mean. Now, this is the empirical rule, and Carl is the gnome who came up with it. For a normal distribution, basically there are certain properties that we can assume. 68% of our data points are mounted up on top of the bell curve. Over there, one standard deviation away from the mean. 95% of our data is 2 standard deviations away from the mean, and if we go out by another standard deviation, at 3 standard deviations away from the mean is 99.7% of our data. Now that's all good. Unfortunately, we cannot really use that for monitoring, but we're going to get into that in 1 second. So what kind of data does this apply to? The empirical rule typically applies to the real world data, and that is, for example, age of Nobel Prize winners. And when I look at this graph, I'm hopeful. Other examples are baby weights. If any of you had babies, then you may know about this. Basically, when humans produce babies, they have the distribution of like 1 million babies' weights for the statistical category, and then they look at it, and they look at the baby's weight, and then they decide whether the baby is in a healthy percentile with respect to 1 million babies who were produced from the same category. Or height data, for example. So in monitoring, like we said, we typically have skewed distributions. And as the distributions are skewed, we really want to care for the long tails, for example, of latency. And how do we measure that? Like, how do we understand better the long tail in latency? So one of the ways to measure that is to look at relative standing of things. And we understand best relative standing. I think we understood this when we were taking exams. So if you took an exam and the mean was really, really low because it was a really, really hard exam, it didn't matter that you scored low. What mattered is how well you scored with respect to everyone else. And same thing with an easy exam with a high mean. I really like this analogy for percentiles. It says in a race of 100 people, P99 is the time for the 99th person to cross the finish line. And this is my half marathon percentile. So what is Kate percentile? It is actually the observation value or the data point that divides the data into two sections, two parts. The lower part of the data represents the Kate percent of the data that is below this value, and upper part of the data is 100 minus K percent of the data points. So in this case, this would be a physics test score for a norm. That would be the Kate percentile. Quantile is just a generic term that covers more, right? So quantile is the cut point when you chop off your data, and in the case of if you chop your data into two parts, two equal subparts, that is a two quantile, also known as a median, also known as a P50. And 100 quantiles is when you have a lot of patients and you chop your data into 100 pieces of equal subparts, and that is called a percentile. Phi quantile is a term that I see in Prometheus, and it is basically the number that is ranked at phi times n across n data points. So we seem to like to refer to things in different ways. So we're going to look at an example. How do we calculate percentiles? And this is a very naive implementation to find P90. We have 13 data points of exam scores. So what we're going to do is, since we want to find P90, we're going to say 0.9, which is 90 over 100 times 13. And then we're going to round that number up to 12. So it is the 12th data point here. 77 is P90 or 0.9 quantile. And 90% of the scores are less than 77 here. And 10% of the scores are higher than 77. So in US, the Census Bureau actually publishes the household income dispersion. So you know your own income, and you now know everybody else within the US what percentile and what income maps to that percentile. So now you can identify which percentile you're in across all of the United States. Another thing that US Census Bureau does, in addition, is to measure the income inequality based on the highest percentile and the lowest percentile, and that is called the Gini index, and that has been increasing lately, so that's not a good thing. One thing about percentiles is that they have universal interpretation. So it doesn't matter what type of data we have. We could be having salary data, weight data, latency data, or non-physics test scores data. 95th percentile always means that same thing, which is the value that ranks at the location of the data where 95% of the data points are below it and 5% of the data points are above it. And it doesn't mean the mean or the standard deviation of these data points. It doesn't matter, sorry. It doesn't matter what the mean or standard deviation for the data points are. So this is an example from the Google SRE book that is showing P50, P85, P95, P99 latencies. And on the y-axis, it is logarithmic because it is covering a wide range of values from 1 millisecond up to 10 seconds. So what it's saying to us is that typically the requests are taking 50 milliseconds, which is pretty good. But it is also telling us that 5% of those requests are going to be 20 times slower. So P95 is at 1 second here. And it is even telling us further that 1% of our requests is even slower than that, so it's at 5 seconds. So we really do want to care about those higher order percentiles and observe them and optimize them. Because in a distributed system, even 1% of the requests could have effects in the downstream, clients. Now, how do we calculate percentiles in the real world? So what we typically have in the real world is that we have billions and billions of values, especially when we're monitoring. If we have services that are generating maybe 1 million requests over 1 million requests per second, for example, and if you need to find the P50 over a 24-hour period, then if you do the math, you end up with 86 billion values that you would need to sort, first of all, store, sort, and then find the middle point. So that's a lot of values, and that doesn't scale. So what we need to do is we need to approximate it. And to approximate percentiles, we actually have existing compressed data structures that we can use. And these are things like T-Digest, which has a beautiful paper by Ted Dunning that I urge you, it's really easy to read. It is made really accessible to all of us. I think it's awesome. Greenwald, Kana, HDR histogram are a few of the other ones. So there's quite a few of different ways to do this. But what all of these things do is they read in stream of data points, and they approximate at any given time the kth percentile value for that streaming data. So these are my key takeaways for you today. Log scale graphs work to show the contents of the entire universe. So if you need to show a wide range of values in a compact way, then they're good for you. It's good to observe the long tail of your latency with high order percentiles. And the last two are about statistical potholes not to fall into, which is averages, they get skewed by outliers. And percentiles that we use in monitoring are most of the time approximated, so we have to be careful about what we do statistically with them. And with that, I'll end it. Thank you.
Amazing. Awesome, that was great. Do we have any questions for Lorna? Look around here. Just a reminder too is we do have every speaker has their own dedicated channel. Feel free to pop in there, as well as just in person as during the break times and everything else. Awesome, thank you so much. Another big round of applause for Lorna. All right, as I mentioned, usually around this time yesterday, this event would not be possible without the amazing sponsors. Make sure you do spend some time to go and check them out. A lot of great swag, a lot of great socks, it looks like. I think the hoodies yesterday went super quick. Especially it was a little chilly in here, so I think that was something that was great to keep people warm. All right, so we've got a series of 3 amazing sponsors. They're going to give us their best 5 minutes, and then we'll continue on with another talk after. So let's give a big round of applause for MoogSoft.
Good to be here. I'm Richard Whitehead, Chief Evangelist and CTO of Observability for MoogSoft. MoogSoft is the company that brought AI and machine learning to IT operations. Somebody yesterday quipped that there are 2 types of AIOps products, new and dead. Well, we turned 10 years old last year, so that makes us a bit of a paradox. As my job title suggests, many people, including my marketing team, said I was going to come up here and talk about observability. And why not? I'm qualified. I think I recall I studied control theory when I was in college. But the other day, a couple of weeks ago, in fact, I discovered that the British actor, Rowan Atkinson, not only has a degree in electronics, but he got a master's in control theory from Queen's College, Oxford. So yes, folks, Mr. Bean is better qualified to talk to you about observability than I am. So I'm not going to. Instead, what I'm going to do is I'm going to use the few minutes I have to do a shameless plug for our State of Availability report. Every year, we conduct a report on availability. We typically get over 1,000 responses, so it's a pretty good report. And I'd like to encourage you to go and swing by our booth. And if you're in the slightest bit interested in what we do in terms of AI ops and why companies like American Airlines and Uber trust us, go and ask a question. Your curiosity will be rewarded. So what I was going to do is basically give you a couple of tidbits that I personally found really interesting from last year's State of Observability. One interesting thing was we found that of the thousands of people who responded, on average, the teams are using over 16 monitoring tools. That's actually a significant increase over what I would have expected maybe 10, 20 years ago. Some actually have as many as 43. And I distilled from some of this information an interesting correlation. Correlation is what we do. That there's a very close correlation between the more aggressive SLA and the number of tools that people have. The higher the SLA, the more tools people have. Okay? What I also discovered is that there's a high correlation between people who have aggressive SLAs and people who meet them. So that's interesting too. If your SLA is lower, people tend to fail more often. So that's one interesting tidbit I would give you. I've lost my timer. Oh, we've got 2 minutes left. Another interesting tidbit was more kind of like, for me, emotional. And that is that the upper echelons of management in organizations don't really appreciate how much time and effort people are putting into monitoring. This is a verbatim quote. And to me, that was kind of very personal. I'm like, wow, that's an awful lot of effort that people put into monitoring, and it's just largely overlooked by upper management. And that's something I think that we as a collective group need to fix. Another tidbit is that 45% of the time, customers report outages before tools do. And it's like, that's another problem we need to fix. So again, I would say that as a company, we tend to focus on things like mean time to detect. Okay. So talking about mean time to detect, sorry about this, you can go grab the report, you can read it in more detail. What we found is that mean time to detect is being tracked maybe about 15% of the time. So when tools are reporting problems, the timer starts at the point at which a problem is identified. So mean time to recovery is being tracked. In other words, the amount of time that the duration of the outage has been tracked has been reported. But the amount of time it takes to discover when a problem occurs is not being tracked by any kind of tool. So we're trying to put a focus on mean time to detect. Okay. And so here's the shameless plug bit. Please come down and participate in our State of Availability report. It really is a relatively straightforward report. You can do a survey very, very quickly. We'll give you a t-shirt. And thank you very much.
Great, thank you, Moogsoft. I don't know if anyone was here last year. Jason and I had a speaker that fell out, and we did some conversation about how logos changed over the years. And Moogsoft was one of those ones that had a couple of iterations. So it's fun you stuck with it this year. We like that.
Three years in a row, same logo.
3 years in a row, same logo. You can't say that for everyone. Awesome. All right, well, our next speaker is going to be Jeremiah from New Relic.
Awesome. Hey, everyone. All right, so let's see. I got you all for 5 minutes. 5 minutes, 53 slides. Let's try to figure it out. No, not really. I have, I think, 5 slides with 3 main points, right? Legal. I'm not going to say anything interesting enough for you to trade on, but don't do it if you want to. All right, so I think most of us in the room are here because we build, run, or maintain some form of software. Show of hands of folks that know New Relic, or have used New Relic, has heard of New Relic. it's most of the room, all right, so I don't have to do a really deep introduction, but basically New Relic is all-in-one full-stack observability platform with our engineering headquarters actually based about 5 minutes away from here in Big Pink. I moved to Portland a few years ago when I joined the company, so near and dear to my heart to be back in Portland now after being back home in Miami. But back to the platform. So New Relic is a full-stack observability platform that allows you to see what's going on with your metric events, logs, and traces in context in a single pane of glass. So the platform itself gives you all of your data within one location built on top of our NRDB database. So it takes all of your information, correlates it, and allows you to understand what's going on with regards to the performance of your system. Within the platform, we have over 30 capabilities built in and continuously building and releasing new features on a quarterly basis. So if you haven't had an opportunity to actually get into the platform, or if you haven't looked at it in a while, I'm pretty sure it's vastly different from the last time you've been there if you haven't used it in the last year or two. But we're constantly releasing new features on a regular basis, recently introducing New Relic Grok, which is now allowing you to actually use large language models with your telemetry data to create a ubiquitous platform that allows anyone within your organization to have access to that data just by using your natural language. I think with 5 languages supported out the gate. So rather than you coming in trying to have to figure out what's going on with your performance of your system, you could just ask New Relic now, hey, how many users did I have in the last week? And the platform will tell you that. So that's one of the main points for me to highlight what New Relic is and what it does. The second one is our pricing tier, right? So most of the folks in the room are familiar with the platform. I'm sure you remember that we used to have a bunch of different SKUs and a bunch of different services. In the last few years, we moved to this all-in-one platform and created a new pricing model, which is the free tier, right? So it's free to sign up, free forever, no credit card needed. Out of that, you get a full free user that has access to all 30 capabilities. You get 100 gigabytes of data ingest per month. So as long as you never go over that 100 gigs per month, you never have to insert a credit card. And then with that, you also get unlimited basic users that have access to things like dashboards and other parts of the platform, whereas the full user has access to the entire platform. So this QR code will take you to a sign-up page. If you want to get hands-on, actually instrument, see what's going on with your data, this is going to be one of the best ways to get started by trying out the free tier. And my last one is just thank you. Thank you for attending this event. I think that these types of events are incredibly important to keep the community growing. Thank you for allowing us to sponsor. And I hope you all are enjoying the rest of your day here at Monitorama.
Awesome. Thank you so much, New Relic, for being a continual sponsor. All right, and our last sponsor before our final talk before lunch is going to be, there's no Google Slides on this one. All right, let's give it up for Squared Up.
Hello, thank you. So I'm Jason, this is Chris, we're with Squared Up. So if you haven't come to the booth upstairs and talked to us, you might not know who Squared Up is. We haven't been to Monitorama before, it's our first time. So Squared Up is a unified visibility layer, sits across all of your engineering data. So that means what we're not is another observability tool. We're not a monitoring or an observability tool. We don't collect all that data, and we aren't yet another data store. So we provide unified dashboards and analytics across that data. So what we do here is we like to come to these events with our bright colored shoes. We like to give away Lego as our swag, so we've been doing that for a few years. And since we like Lego, we like Star Wars, we like monitoring, we thought we would monitor our Lego Star Wars swag. So that's what we're doing. The tech stack, we actually built an app for this. So if you come to our booth, we actually built a swag app, and the tech stack behind that app is hosted on AWS. It's a serverless app. We're using GitHub for the code repo. We're using Azure DevOps for our CI/CD. We're monitoring that app with our observability tools of choice, Dynatrace and Pingdom, Zendesk for our ticketing. And what we're going to do is just show you a quick demo of how we're doing that with Squared Up. So switch over to Squared Up. So when you come to the booth, you actually kind of build your own Lego Jedi. I'm going to put up a QR code at the end of the presentation, so hopefully invite you all to participate. And what we have is Chris over here at our booth is going to build that Lego for you, and he's doing it in an average of about 2.25 minutes. And these are the popular Legos, and that's the orders that are fulfilled. We're also collecting a lot of data from people that are filling out the information on the app. So we're curious what KPIs are interested to you all as you're monitoring, and it's things like monitoring the cloud hosting costs or even the observability costs, monitoring MTTR. SLOs has been a big theme, SLIs and SLO monitoring. But you think a lot of developers we're talking to are monitoring their pipelines. And then the right side over here is talking about the tools. Sorry, the tools that you all are using. So Grafana is a big one, not surprisingly. PagerDuty, Jira, GitHub. So we're getting a lot of information. Hopefully this resonates with a lot of what you guys are seeing and doing because it's your data. Thank you guys for participating in that. And then, so what we have is this Squared Up, like I said, it unifies visibility across all of your engineering and data stack. An example dashboard of that is kind of this data from everywhere. We're monitoring metrics from AWS. We're monitoring pipelines from Azure, DevOps, and Circle CI. We're looking at custom queries from Elasticsearch, incidents from GitHub. So wherever that data lives, again, we bring it together and Squared Up as that kind of unified visibility layer that sits on top of all the data. It's for the teams that are trying to, they don't have the problem of not having the data. They have the problem of maybe too much data. They want to surface insights from that data. They want to share those insights across their organization. They want to get better kind of meeting from that data. And so you can start to shape that data into different views across different teams. Here's an SLO dashboard. Again, this is kind of all modeled after that Swag Store app that we've built. So this is SLOs for that Swag Store app. This is the cost to host that app in AWS on serverless. It's not too much. We've got incidents that we're tracking, we've got the pipelines that we're tracking, and all that data can be rolled up into a big picture view across. So we have this fictitious company, it's Squid Inc. And one of the critical apps that Squid Inc. is monitoring is that Swag Store app, so I can filter down. And you get that, what we find is missing so often isn't access to all the data, it's the big picture view across that data. It's that simple red, amber, green dashboard that you're going to share with your boss, share with your colleagues across teams that maybe depend on your services. So here's that Swag Store app, and again, you can drill into that and see what's going on and take you back to where we were. Help from all the dashboards is rolled up. So I'm going to flip back to our presentation, summarize kind of what we do, how we do it differently. We're designed to give you that big picture view like I talked about. And what we do is we built this on a data mesh architecture. We're not a data warehouse, we're not storing it. We stream the data in place so it stays where it lives and we don't have to duplicate and pay for all that data. But yeah, right now I'll just kind of invite you all to scan the QR code if you want to build your own data Jedi. Chris is going to get back in the booth. Actually, we got somebody there right now. They're going to build it for you, put all the pieces together. We got all the inventory over there, and we'll deliver it to you in this nice little pillow box. So if you want to participate, get a Data Jedi Star Wars swag. So thank you all. Thanks for listening about Squared Up, and good to see you all here. Cheers.
Great, thank you. I'm glad the microphone wasn't on because my voice just cracked hilariously. So, saved. Thank you, audio team, for being delayed on that one. Thank you, Squared Up, and all of our sponsors again for being a part of this event. And again, show your support of these sponsors by heading up to their booth and checking it out. They're all upstairs and they'll be around all day today and all day tomorrow, or probably half the day tomorrow. So awesome. Thanks so much. All right, our last speaker before the lunch break is going to talk even more about math, which is pretty amazing. And I love, again, I said this yesterday, that my favorite parts of these single-track conferences is how talks get to build on each other. So being able to get deeper into the math and the numbers behind these numbers that we are capturing and collecting with observability is very important, right? And that's the fun part about this job. I see, and Google Sheets. You're going to rebrand it. Do you remember there was an Apple engineer, I don't know if this was real or not, that was so annoyed with Apple tickets in their wallet that would not expire out. They got a job at Apple to fix the bug and then quit. I don't actually have any yearning to go work at Google other than to go and fix how the notes do not work in Google Slides. So anyway, with that being said, I will leave it to Cliff Moon. Oh, wow, that sounded terrible. Let's give a big round of applause to Cliff.
Thank you. Hi there. Everyone hear me all right? Yeah? Cool. So I am standing between you and lunch right now, so let me be quick. But first, introductions. So my name is Cliff Moon. I work for a company called LinkedIn. You may have heard of it. I'm going to tell you about some of the work today that my team has been doing. In particular, we've been adding performance visibility to our A/B testing platform. Some introductions here. I've been on the performance team at LinkedIn for almost 5 years now. Before that, I have been involved in the observability and monitoring world for about 10 years or so, maybe a little bit more. And I've been in various startups, having co-founded, CTO, VPN, everything in between. So yes, I've been around a while. And also, I work remotely from the woods of Western Washington. So I feel right at home here on the stage. This actually looks quite a bit like home. Since I work remotely from the woods on a farm, I figured instead of the usual stock photos of people in the office, I'll show who's in my office a lot of times. Not actually, but you know. Okay, so a quick note up top here. As with all large, projects that come out of large companies or things that come out of large companies, we have problems that may not exist at much smaller companies. And so don't just go and implement this. Like, think clearly about the problems you have. A lot of what I'm talking about are problems born out of scale. Not just scale in terms of like how many requests we get or the data we're working with, but scale in terms of like how big our engineering team is, how much change and churn is going through the code base. That being said, I hope even if this is not a problem that you might have, I hope that the approach that I sort of put forward here on how to do research and how to apply it is something that maybe you could bring into your own practice regardless. Okay, so I want to talk a little bit about my team and what we do. So we have a team as part of performance in LinkedIn called SiteSpeed. And as part of SiteSpeed, we measure and monitor performance from the perspective of the member, right? So anyone who uses LinkedIn on a device, on the website, anytime you interact with LinkedIn as a part of the public, we instrument the performance from your perspective. So how long does the page load take? How long does the page load take? How fast do you get results on your screen? And so this is very much what you would call like real user monitoring, right? And we call it, and the highest priority metric for us is that PLT, the page load time, which is our proxy for how fast do you get results. So we maintain libraries for all the developers inside of LinkedIn to instrument their code. We track this performance by something we call page key, which again, as a matter of scale, how do you split up performance in a really large website like LinkedIn? Page key is what we use to kind of narrow down on various pieces of ownership. So a page key roughly proxies to a team somewhere in LinkedIn. So thinking about things like feed, messaging, all the various parts of the website that you interact with, that's owned by a team somewhere. And then we give them a fine-grained ability to see page load times for the piece that they own. We do aggregations on these metrics. In particular, we focus on P90. We've all heard about percentiles here this week. I think math is kind of a theme at Monitorama this time. So yeah, we focus on 90th percentile in particular because obviously averages lie. We all kind of know that. Response times do not adhere to a normal distribution. And so when we enforce SLAs against these page keys, we do so via P90. We have what we call regression tracking, and then this is really just our SLA enforcement mechanism. So we have automated systems that, once the page is in breach of its SLA, we open tickets against those teams, and then we give them help and support in helping fix those problems, helping get their page back into SLA, making sure we're giving a good experience to the LinkedIn members. So we also have an A/B testing system or an experimentation system. It is called Lix. It's a fully internal tool, but I just want to introduce it because what I'm going to be talking about today kind of dovetails in with it really closely. But as an experimentation tool, it provides a lot of support for things like dark launching, feature flagging, so pushing out new code or new behaviors into the website or into various platforms as part of the stack. It gives reporting on broad business metrics. So this is going to become important later, but essentially there's reporting tooling in there, but really it focuses on business metrics. So things that like you're clicking a button, or like funnel activation and things of that nature. So metrics that adhere to a normal distribution. And so a lot of the reporting on whether or not an experiment is moving a metric is all based around, is it a normal distribution? Are you moving an average of a business metric across the entire site? And for reasons I'll explain in a little bit, that doesn't really work for performance. Yes. So I kind of want to introduce the problem that we set out to solve. Here's some stats about experimentation at LinkedIn. As I said, we have a pretty large scale engineering team, and because of that large scale, there's a lot of stuff going on. On any given day, there's over 500 active experiments. So small experiments to large experiments, new functionality being put out there. Any kind of experimentation you can think of, it's going on any given day. So there's a lot. And then, when we take a look back through the regressions that we maintain as part of the SiteSpeed team, what we found was a high percentage eventually root cause down to an experiment. We see that a piece of code got pushed out through an experimentation, and it caused a performance regression. It caused that P90 to slip. It caused us to breach SLA. And finally, there's a lot of parts of the website. We have over 1,000 active page keys. Many of them are very small pieces of functionality that don't get a lot of traffic. Some of them get a majority of traffic. But there's a lot of page keys in the data, and so we need to support as large a slice of that as possible. So all this is to say is that we have a data set with high cardinality, a lot of dimensionality, and what we want to be able to do as the SiteSpeed team, we wanted a way to spot performance problems early. Monitoring page load time, monitoring RUM data. One of the things we find is that, if you remember Adrian's talk from yesterday, a lot of times these distributions that come in, a lot of times the measurements that happen, it's really hard to just looking at the measurements you're taking, it's really hard to even just say, hey, did something change, right? You think about seasonality of traffic, Monday through Friday. You think about like all the various things that might be happening around the world, like on a social media site, it's like, is there a conference going on somewhere? Is there an event happening that's putting this particular pop having more traffic? It's more saturated. There's so many variables that go into our data set because it's a global data set. That is really difficult to be able to look at a graph of P90s day by day and say, you know what? Yep, something has gone wrong here, and I know what it is. It's very, very difficult, and so we have a sort of a built-in kind of bake time that happens where you need to observe the performance for a page, that P90 performance over several weeks before you can definitively say something has changed and then kick off an investigation. So then say we breached SLA. The goal that we had was, hey, let's speed that up, and the way that we're going to do that is we're going to focus on experimentation. And as these experiments get pushed out to a small percentage of public members, can we say if it's going to have an effect once it goes out to everyone? So I embarked on this quest to kind of figure out if we can do this. It was last year, and one of my first questions was, how am I going to compare to quantiles? There wasn't a whole lot of literature around that. And so what I did was I was like, well, it seems like there is a lot of literature on comparing distributions. Maybe that might be useful. So that's kind of where I started my research. And let's talk about research a little bit. So I think one of the most exciting things for me as a software engineer is you have an open-ended problem. You do not know how to solve it. You've never encountered it before. So how do you even go about doing this? Like where do you even start? I've done this a couple of times in my career. It's not often that this happens, but when it does, it's very exciting. This is kind of the methodology that I've come up with for doing research and how to apply it. And I'm not a researcher, I'm not a mathematician, I'm a software engineer. I need to apply things. So that's kind of what I'm gonna what I'm gonna focus on. But sort of the methodology I follow is, one of the first things is you got to find the terms of art for the domain you're looking at. So what I mean by that is like the people who talk about this stuff, the people who devote an academic career to doing a particular thing, there's ways that they have of talking. There's like just keywords, search terms. There's ways they have of talking about their domain that you may not even know. And so how can you even search without the terms of art? Like this is kind of a bootstrapping problem of, you start searching around and you start looking at papers, and then you follow the citations. And by following the citations, you can sort of bootstrap your knowledge of the terms of art, the domain, how people think about the problem, and to start to, develop your model of how to think about the problem. So one piece of caution that I have, though, is that, I've read a lot of white papers in my career, and one of the things you kind of see is that, like, there's a lot of what you see in a white paper, you need to kind of like read between the lines, because a white paper almost never comes with code. They talk about results that they get. You might see a table of data that came from a piece of code somewhere. They almost never publish the actual code. So you got to ask yourself a question of like, where did it come from? Like who published this? Is it academic? Is it from private companies? Is it a combination of the two? When they talk about the system, do they talk about it being in production? Do they talk about having sort of a research test harness? Like, you really kind of need to understand how they applied this, and if it's actually being used in anger, as opposed to just sort of research code that got made to just have the white paper published. And I think the final piece here that I think really helps when you're trying to apply research to a problem is you need to find ways to really quickly test the things that you're reading, the methodologies you're taking in, to try to see what's going to work and what's not going to work, and very quickly throw away the things that will not work. So I'm going to talk about how I kind of did that. So, how did that? Okay. Sorry about this. Where did my... Hang on. Sorry, I gotta go back to Chrome here and try to pull up. Here we go. Are you kidding me? All right. You know what? All right, I gotta do this real quick. I'm so sorry. Apologies to everyone. It's gonna sign me out right in the middle of the presentation. Okay. Yeah. So I will talk a little bit about what was on that slide. So, as I mentioned, one of the first things I ventured to kind of research was, okay, comparing two distributions, right? What does that look like? So there's a lot of research in that vein, and there's a lot of different methods for comparing. In like standard data science. Yeah, like in the standard kind of data science literature, there's a lot of really kind of like tried and true methods for doing that. So there's, I think it's called the KS test. Yeah? Okay, cool. Yeah, got it. Yes, there's the KS test, Earth mover's distance, which sounds really cool. All right, we're going to reload all my images too. Excellent. Okay. Of course, we're going to do...
This is not an unfounded hate, is it? I'm not being irrational.
Okay.
I asked a question this year. If you work for Google, can you please DM me in the Slack? We're fixing this thing. Awesome. We're good.
All right, cool. Yeah, sorry about all of that, folks. Okay, yes. Yeah, all right, we're just going to go to this one. Yeah, so anyways, I went through a lot of different methodologies for trying to compare to two distributions. None of them would work. And I didn't really even understand why. But what finally sort of cracked the code was I finally found this paper from a data scientist at wish.com. And you can go and look this up. I'll post links in the talk channel. But this was like my breakthrough moment, finding this particular blog post, which is like how wish A/B test percentiles. And I'm like, oh wait, that's what I want to do. Cool. But I dug into it, and so one of the reasons why comparing two distributions didn't actually work is this right here. So in an A/B test, you think about statistics, right? Like all of our statistical methods are based upon the idea that when you're taking a sample, it is a fully randomized sample. In an A/B test, the way A/B tests are structured, that is not true, because my measurements are page load times, but the randomization unit is the user, right? So a user is going to have many page load times, and those page load times are going to be highly correlated with the particular situation of that user. So in other words, if you have a good internet connection, then you're going to have lower page load times, and they're all going to be correlated for you as the user. Whereas someone who is at a conference is going to have slow page load times, and they're all going to be correlated as well. And so this breaks the fundamental assumption of pretty much all statistical methodology. So one of the primary challenges to get over is how do you control for this particular for the randomization unit. I'm going to talk a little bit about how we actually do that. Oh my God. Anyways, the white paper. There's another white paper that's actually referenced, and my images aren't loading for some reason, but sorry about that. Anyway, here we go. Perfect. So there's a white paper referenced from the wish.com that actually is a white paper published by LinkedIn in 2017, I think. I'm like, wait a second. Okay, someone else solved this problem for me. That's great. Where's the code? Like, where is this? And this is actually one of the most interesting parts of this is that, usually as an outsider, you don't have the access to be able to say, like, where's the production system? Like, you published a white paper. Where's the thing that's actually running? I'm in a great position here because, like, I have the rare opportunity to actually see, hey, where's the production system that ran this? So, yeah, so I was reading between the lines here, and I'm thinking, okay, where's the actual code for this? And so we have some really good internal code searching tools. I was able to find this internally inside of our code searching system, and then I was kind of like an aha moment. I had actually dealt with this before, and I had no idea what it was. Like when I first got it, when I first got to LinkedIn, this is one of the things I had to fix because what had happened, it turns out what had happened was that the team that did the research, they implemented this as kind of a black box step inside of our data pipeline framework, and it was kind of done as a one-off. And so it was only ever used by the site speed team, and it, eventually, over a period of time, all the people involved with it kind of moved on to other things. And it became bit rot, right? So it started to break. And by the time I got to it, it was this kind of odd, broken thing. No one knew what it was based on. No one knew how it worked. So we kind of had to start over, and we just didn't know what it was. So it's kind of one of these interesting things of like, I mean, thankfully they published the white paper so we could rediscover it. But yeah, it's kind of wild. I was like, oh, okay. Yeah. But anyways, we decided, okay, this kind of worked before. I think this should work again. Let's go through it. So now I want to kind of talk to you about how does it actually work. So we're actually going to dig into the math here. So this is going to look a little intimidating. And I think a lot of mathematical notation is intentionally intimidating. But I want to hopefully kind of break this down for you a little bit. And so the methodology here, so let me kind of back up for a second. What we're trying to get to is that if I'm trying to do a statistical test on a percentile, what I really, and the percentile is just a summary statistic from the data set, right? What I really need in order to plug it into like something like a z-test is I need the variance of that summary statistic. If I can get the variance of the percentile, then that's going to give me everything I need to plug it into the rest of like known, well-trod statistics in order to get my answer of, did this percentile shift in a significant way? And so what this is doing is that we essentially what we need to do is we need to generate a whole bunch of summary statistics from the data set, from each bucket in the data set. We generate our summary statistics, and these summary statistics really what they're trying to do is, remember what I talked about the randomization unit? Most of this is controlling for that randomization unit. So what we do is we find our P90. So the paper talks about P95, but in our case, it's just you just choose another quantile and it works. But essentially, we try to sum up. We try to get the counts and the sums for fast PLTs, so those that are under that P90 cutoff, and then we get the overall counts for these things. And essentially, like again, I don't have a deep understanding of the math, but intuitively, we combine them together at the end to kind of get the variance, and then that variance, it really just controls for sort of that bias in the selection of the users. So, yeah, and so we implemented this. This is actually the Spark code. This is part of the Spark code that runs this, and you can kind of see what it's doing here, right? Is that we're up top here. We're getting a window of quantiles. That window of quantiles allows us to estimate the density of the curve. So we're sort of like getting a numerical integration of the histogram, and then we're also getting our summary statistics down here. And it's just a really simple. I mean, it's pretty straightforward. Like once you again get through the mathematical notation, which is why I wanted to show the code. We're just aggregating this. We're just doing group bys, and we're aggregating all of these different sums of like PLT count, traffic count, and then we're getting the PLT count squared, traffic count squared, and then PLT count times traffic count, et cetera, et cetera. And so and what these PLT counts are is these are the fast ones, right? So this is the stuff that was faster than P90, and these all mix together in such a way that we get. Yep. These all mix together through this equation in such a way that we get the variance. And it's really, and again, looks really complicated. It's actually pretty simple. We're just multiplying some things, dividing some things, adding some things. And in the end, sausage comes out the other end, and what we get is the variance of the percentile. So again, looks super intimidating, actually pretty straightforward once you dig into it. So yeah, what we ended up doing was we went back through, and so coming back to like, how do you test these things? What's the validation? And one of the nice things about LinkedIn is that we have raw data going back for a certain period of time, and so I can go back through historical examples of real life experiments that went wrong, and then I can run these methodologies through a very lightweight test harness to be able to say, hey, is this going to work or not? Would this have caught this incident early in the ramp? And what we found is that it was a resounding yes. We were getting very good signal from historical analysis. And the other thing we started to compare against was the gold standard, which is the bootstrap method. I probably don't have time to go into the bootstrap method, but essentially, like you think about variance, right? Like bootstrap is kind of the brute force way of getting the variance of that summary statistic, where you do several hundred rounds of sampling out of the raw data. You calculate your percentile, and then that set of percentiles, like each round you get this set of percentiles that will conform to a normal distribution. You can take the variance of that from that normal distribution, and then ta-da, there's the variance of your percentile. That's the gold standard. Unfortunately, it doesn't scale because you got to do several hundred rounds, and this adds up very quickly in the data pipeline. So anyway, yes, we validated this. We found that it worked. And then I got the green light from management to go ahead and build it. So now the rubber meets the road. Like, how do you take research and turn it into a product? Because you get really excited about this stuff, and you're like, this is going to change the world. This is going to be amazing. We're going to do all this stuff. But it's very, it's very easy to get sucked into the idea that you've got to build this enormous thing. You're going to change the world first, in the first go round. So what we decided to do was, let's narrow this down to a very, very small set of use cases and try to provide value with just the bare minimum. Try to get it done in a quarter kind of thing. Like let's just get something out there And it's funny because like you think in a big company everything has to be built to the nth degree. No, the way you innovate in the real world and in public, same way you innovate in a big company. You got to get your stuff out there. You got to get in the hands of users. So what we decided to do was focus on a very simple use case for the developers at LinkedIn. Like I said, there's this page key ownership model. And this ownership model allows us to be able to find the teams for these pages. And we just built a notification system for them, right? Every single day, we take a look at all the new experiments that are coming online within the past however many days. We take a look at new experiments. We do this methodology. We do the statistical testing on them. And we can tell them with a high degree of certainty whether or not their experiment is having an effect on that page. And the cool part about this is that this is kind of the foundation we've decided to build, further work on top of, because once we get this like small list of pages that we know are having an effect, we can then start to do more expensive calculations, right? So if you think about stuff like, okay, you've told me my PLT has shifted because of this experiment. That's great. What next? How do I root cause that? And so what we want to be able to do is we want to be able to do the same type of statistical analysis on all of the metrics that are happening. And think about the distributed trace. Think about all the services involved. Think about all the phases that happen in the browser or in the mobile app. We want to be able to zero them in, have automated root cause detection, to be able to tell them exactly what changed with their experiment, so they can fix it quickly before it impacts a majority of our members and before it gets in the way of their development cycle. Makes them faster, makes the members happier, makes the website faster. So everyone wins. So yes, so the conclusion here, again, you might not have this problem. You probably don't have 500 experiments per day. I hope you don't. But this may be useful to you, but even if it isn't, I hope at least my approach to doing this kind of research and applying it can be useful towards you. And I think that the last point here, I really want to hammer home, you really got to be biased towards results. Your job as a software engineer is not to produce research. Your job is to solve problems and produce working systems. And at least in our case, at Monitorama, our job is to make the lives of the developers a lot easier. And so, that's what biasing towards results means to me. You gotta get it out there, get it in the hands of users. And so finally, this was a big team effort. I'm the only one who was able to come out here, but I really wanted to give a shout out to the teammates who did, honestly, the majority of the work. I'm just kind of the talking head. Tin, Abhijit, Pawan, Saurabh, great team of folks, and they did an awesome job building this. So thanks, guys. Yeah.
I feel like I'm living vicariously through Cliff because he's got this really awesome hobby farm, and when you're in tech, every once in a while you're just like, I should just farm, but it turns out actually a little bit of work, right? Yeah. Yeah,
it's a lot of work, but I also do tech too, so it's I just have double work.
Double work. Awesome. Any questions here for Cliff before we start our break? I got a question right here.
Are you using the results of that to gatekeep, as a gate for full rollout?
Are you using the events as a gate for a full rollout?
Oh, that is an excellent question. So that's kind of some of the further work that we're doing. I kind of adapted this talk from a talk I gave inside of LinkedIn, so it was a very difficult question for me of what's actually relevant to an audience that's not internal. But yes, we're working with that, the experimentation team to do that kind of integration, to be able to essentially have it be a guardrail metric, so that you block ramps at certain percentages or roll it back if it's extra egregious. So we're working up the heuristics for how the decisions get made that way and automate them. Yeah.
Question right here. How do engineers at LinkedIn answer the question, what changed? That is a great question.
I think that's kind of the heart of this work, right? Is that, as I mentioned earlier, we look at least on the SiteSpeed side, we look at a global data set that has so many variables in it and so many dimensions in it that it is incredibly difficult to be able to say what changed, again, without that that period of time to see the shift in trend. You know what I mean? So what we're trying to do now is we're trying to focus in on these particular use cases where it doesn't cover 100% of everything, but we're focusing in on particular areas where we know change has been introduced, right? And so it kind of turns the problem on its head. So instead of looking at a global data set and saying what changed, where we know what changed. We know that an experiment happened and that a feature dark launched. So the question is no longer what changed. The question is, hey, this thing changed, did it do something? Did it have an effect on the metrics we care about? And that's an easier question to answer than what changed. That will not get everything, but again, it's a matter of you can't boil the ocean. So focus in on the heavy use cases, and that will automate away a lot of the pain.
Great question. One right here in front.
Yeah, you mentioned some of your page keys are don't get exercised that often. There may be like a page that doesn't load right up. How do you approach sort of the challenges of trying to, what does it mean to have a P90 of a page that only loads like once a week or something like that?
Yeah, what does it mean to have a P90 of a page that's rarely loaded?
Yeah, that is a very insightful question, and it is it's a question that we ask ourselves on my team quite a bit. We don't have good answers for it right now, but it is something that we're trying, because you're right. There's parts of the website where performance still matters because they're for maybe they're for people who are paying and et cetera, or maybe there's all sorts of flows. And I got to be careful about what I say, but there's all sorts of flows through the system that might not be exercised so much, but the experience still matters. We do not have amazing answers to that right now. But it is something we're kind of actively thinking about, how to address those use cases without throwing away all the other stuff we built. It's a tough problem. Yeah.
There was one right here. Yeah, right here.
So I kept hearing the theme of great white paper, where's the code? So I'm going to ask, great presentation, where's the code?
Great presentation, where's the code?
Yeah. You got me. I mean, that's kind of the thing, right? Is that how should I put this? You ever seen the movie The Gods Must Be Crazy, where it's about it's like a weird 70s movie, but the essential idea is that an airplane's going over like an undeveloped area. They throw a Coke bottle out of the window, and then some folks on the ground pick up the Coke bottle, and it throws their entire world into disarray. I kind of feel like large companies do this a lot. Of here's this incredible piece of technology. We're from the future. Ta-da, and then no one knows what to do with it because they don't have the context for that technology. I'm trying not to do that, and so that's why I'm trying to focus on more generic of here's how you do research and apply it. Here's an actual research methodology. I think that it's fairly straightforward to take the white papers I've referenced, and I'm going to put them in the chat to actually go and implement them. I can't open source the code that we have to do this because it's entirely too context dependent. There's an entire world of data pipeline frameworks that go with it that simply would not make sense in another context. So it's something I'm sensitive to, and you're right, you got me. I wouldn't be, it's like, do I do this talk? Do I not do this talk? How do I make it relevant to this audience? I hope I tread that line, but maybe I didn't, and that's fair criticism.
Awesome. Any other questions for Cliff? Wave your hand wildly. I can't see it. Awesome. All right. Oh, wait. Oh, you got in under the wire. I was almost going to say.
I was just curious how often you see interaction between, do you ever see confounding aspects because of interaction between experiments that are happening simultaneously?
Do you see confounding aspects of interactions between experiments? That's actually really interesting.
Another, incredibly insightful question. Yes. There is some internal affordances inside of the experimentation framework for doing that on purpose. So in other words, if you have an experiment that has to go along with another experiment, there's ways of forcing it to go and do that selection. But yes, interactions are possible, and especially on lower traffic pages. So we have, internally in the system, we have some traffic cutoffs where the numbers simply won't make sense. So it just won't work on others. So we just don't support it. There's also other issues where, if you have an experiment that relies on some aspect of the user, right? So if it's only premium users in this market, and if you have a very finely grained targeted experiment like that, there will be bias in the experiment itself. And so that's where you got to be kind of careful of, is the experiment itself setting up bias? We don't have a great answer for that right now. This work is getting us from, we have a table of tens of thousands of numbers to look at, to we have a table of maybe 20 numbers to look at. And we're going to get further, but it's already been like a leap. but yes, that is a problem we want to address. We just got to do some research to figure it out.
Great. Round of applause for Cliff and his goats.
Hi. Is this on? Yeah. Okay. Just a quick notice. I guess we're going to send a message to everybody to let them know we're looking into the internet issues, but if you don't have access to the internet, you're not going to get the message. So anyways, we have reached out to the internet provider for the venue. They've escalated it. They're looking into it. They are seeing some issues, and hopefully we'll have it resolved by the time lunch is over. But either way.
What time?
2 o'clock. 2 o'clock. Next talk at 2 o'clock. Have a great, nice, extended lunch. I just finished half of my sandwich from the Baker's Mark. Strongly recommended. Yeah.
That's it. Go get a Baker's Mark. Godfather sandwich. Delicious. Enjoy. right, hello everyone, welcome back. How was lunch? Was it good? All right, there's been a lot of different restaurants in the Slack. Who went somewhere that was not in there? Who like ventured out somewhere interesting? Anywhere? Where'd you go? Where'd you go? I don't even know what that is. What kind of food is it? Sandwich shop? Oh yeah, nice. Really good, yeah. I was gonna say the Baker's Mark is the one right next door. I know that was in Slack, so it doesn't count, but highly recommend if you're looking for something close. All right, now that we're fully fed and ready for our food coma, it's a perfect time to do more monitoring talks. This is actually a really exciting talk. We've had a lot of people from this company at Monitorama over the years, and it's really fun to watch the evolution of really observability at scale. So why doesn't everyone give a big round of applause for David?
Hi everyone. Hello. Hello. Can you hear me? Cool. So sorry if my voice is a bit hoarse. I'm still recovering from a cold last week. So anyway, I'm going to talk about how to scale observability without bankrupting the company. And the reason I chose this topic is because I think a lot of people, this was actually mentioned yesterday in Joe's talk, are dealing with this tsunami wave of observability data. But we're all under pressure to keep those costs down, especially in this current environment. And so I figured I'd share some of the ideas that we've already done on how we've controlled costs at Netflix at our scale, but also talk about some of the ideas that we are working on to solve this problem going forward. So just a bit about me. I've been a serial founder. I built and sold a couple of enterprise SaaS companies. The last one was called Dataloop.io, if any of you guys remember that. We actually launched at Monitorama in 2014, so that was my first time coming here. And it was an observability startup competing with things like Datadog and all those cloud monitoring tools back in the day. And my other claim to fame is I actually built DevOps Exchange. It's the world's largest DevOps meetup, about 12,000 members worldwide. So if you're in London, San Francisco, or any of the other cities it operates in, check it out. And after we sold the company in 2019, I took a year off, and then Netflix, which used to be one of my largest customers, approached me to basically head up the telemetry engineering team, which is how I ended up at Netflix for the last 3 years. And then my other kind of claim to fame, which I'm quite proud of, against my marketing team's wishes, we did this campaign at Monitorama 2016 when it was still funny to make that kind of joke about make monitoring great again. In November, it wasn't so funny, but it worked in July. Anyway, so what do we do at telemetry engineering? So the team that I run, we have 9 engineers in total. We essentially are responsible for all the collection and agents and storage, processing, and query of all our observability data across the company. So you can imagine that's quite a big scale. And we provide all the APIs and everything for our alert services to sit on top of it, and all our UIs and everything internally. So all our observability products basically rely on us to provide the data so they can see what's going on with their systems. And we have to do that. This is our charter at the bottom. We have to do this in a performant, reliable, and cost-effective way. So what kind of scale do we operate at? Well, as you can imagine, we're a global online company, so we have quite an immense scale. So on average, we're doing about 17 billion metrics a day with about 2-week retention in hot tier. We're doing about 1.5 petabytes of logs a day, again with 2 to 6 months retention, depending on the different apps that we're collecting logs from. And then with tracing, we're storing about 700 billion trace spans a day with 2-week retention in the hot tier. Which is a very heavily sampled number, so definitely not all the tracing that we would like to collect. So as you can imagine, there's petabytes of data coming into our systems every day, and we have to store it for 2 weeks in hot tier, and then we use S3 for longer term storage. But one of the things that we've been pretty good at is we've actually done a really good job of controlling our costs. Now these scales are not, not equivalent. So even though that number is halfway to the metrics number, it's not the same. I can't share our costs, but I can at least give you an idea of like how the costs look like as our metrics load went up over the last few years. So you can see as we scaled up to 17 billion metrics, we've actually reduced it a little bit recently. Our costs have been pretty linear and flat. So we haven't really gone up exponentially with the amount of data as a company scaled up. Another way to look at our kind of value to the company, how we earn our salaries, is in December I actually did an exercise to look at like a bunch of vendors and just looked at basically our log monitoring solution. So we do 1.5 petabytes a day. When I went out to market, you can see the tiny little red thing there is how much we actually cost per year. And then those are all the other vendors. None of the vendors could even get in the same ballpark as what we're able to do. And that's actually one of the, this is a constant question we get inside Netflix and externally, is like, why didn't you buy, why are you building all this stuff internally? This is why we build everything, because we can do it way cheaper than what vendors can offer us. Although we are willing to work with vendors who can get us into that ballpark. And Joe talked about kind of monitoring costs, kind of getting out of control yesterday. He made a comment that Roy, one of my predecessors, said that we used to be at 25% in terms of our infrastructure costs for observability. Can anyone hazard a guess if we're above, below? Anyone above 10%? 5 to 10%, which is a typical range. Below 5%? Okay, so the people who said below 5%, that's pretty much where we are today now. So we went down from 25% of the infrastructure cost. We're now about 4.7% of our infrastructure costs just spent on observability infrastructure. So how do we do it? How do we get to those numbers and make sure that we don't bankrupt the company as the amount of data goes up? So in the beginning, we were quite traditional. So Atlas is about 11 years old. And Atlas is our in-memory time series custom database. You can go into GitHub, it's open source. We basically did what a lot of monitoring tools do, which is we wrote all the data into the time series database, and then for alerting, we'd basically run every 60 seconds a cron job that would go into the query service and query that database to basically check if an alert had triggered or not. So had we continued with this model, it worked when we had thousands of alerts, but when we get to hundreds of thousands of alerts, this started to break because it meant that we basically had load from both sides. Not only did we have to write all this metric volume into the database, we also had to run every 60 seconds more and more queries that just kept hitting the database, and adding load to the thing until we would have had to add loads more Atlas nodes just to kind of scale with that load. So we took a different approach. We moved to streaming. And this is, if there's one thing you take from my talk, if you can do stuff in the streaming path, you should always do it in the streaming path. It's way cheaper. It's way, it has a lot of benefits, but it's way cheaper. That's really the key kind of source there. So how do we do it today? We basically stream in all our metrics, logs, traces into ingestion. And now, in real time, our ingestion service forwards on basically all the queries that we need for our alerting system in real time to the alerting service that then does its evaluations and basically triggers the alerts. So not only do we get lower latency, that also has allowed us to scale to millions of alerts today without having to basically add a huge amount of infrastructure to support that. So it's been very cost effective for us. And now we really just use queries just for dashboards and for user queries and things like that. So it reduces the load on the database as well. So how does our streaming architecture work? Well, we didn't go down the route of building it on Kafka. That would have been super expensive because you can imagine as we have this tsunami of data coming every day, petabytes of data every day, if we had to write that all to disk, manage a huge Kafka cluster, it'd be super expensive and super hard to manage at scale. So actually, we came up with something that's pretty simple. The trade-off being that, unlike Kafka, we don't have that resiliency. We could lose some metrics from time to time. However, the amount of time that actually happens is very, very rare. And this gets us significantly cheaper kind of streaming capabilities than we would get on something like Kafka. So how does our streaming service actually work? Well, essentially, we have subscribers. So alerts could be one of our subscribers. Inside, we have this library called an evaluator. As we submit queries from alerts that we're basically evaluating, the evaluator adds it to the query index. And the query index is basically, this is kind of like the bit that, took a long time to get it really working and right. And essentially what it is basically, it's just a super compact, super fast lookup index. It dedupes like duplicate queries and stuff like that. And basically just enables you to store it in a few hundred megabytes of memory. And the reason we want to do that is because we want to load that in another library called Atlas Registry in all our ingestion services and some of our sidecars as well. And we want to load that index in, and in real time, as every single data point streams in, log, trace, what have you, we want to do a real-time lookup. Does this match any of the queries in my in my index at the moment? And if it does, we forward it on to LWC, which is the name we call our streaming service internally. If it doesn't, we just forward it on to write in the database or storage as normal. In fact, well, everything gets written into the storage, but the only thing that gets forwarded to our LWC service is the stuff that matches stuff in the query index. So what happens when it gets to LWC API? They're really just dumb proxies that have, that when you go back to the beginning of it, where the evaluator library essentially connects to LWC using WebSockets. It says, these are the range of queries that I'm interested in. Please forward me on any data that you receive, through WebSockets. And so essentially, the ingester matches against all the data, it pushes it into LWC, and then LWC then pushes it into the evaluator, then does a final calculation to create the graph or what have you in the subscriber. So it's a very cost-efficient way of doing it. And all of this is open source, by the way, so you're welcome to go to our GitHub repo and check out how all that code works for the registry and the library and the evaluator and LWC. But one of the other cool things about it, it enables us to do really high cardinality metric queries very cost effectively. So, we would not want to store, for example, a metric that had request ID on it. That would add billions of metrics to our time series database. But in LWC, you could push something high cardinality, maybe not that high cardinality, but something in that range. And we can also do it at high granularity. So in our time series database, we store everything at 1 minute intervals. You can actually push data at a faster frequency with more cardinality. And because we're doing it in the streaming path, it's actually very cost effective for us to basically do aggregations and filter out all the metrics that we care about using that streaming path. So this is something that we're really excited about. And actually, we added it last quarter to logs and traces. So before we were only using it for metrics. Now we're doing it for all of our logs and tracing as well. So essentially, we made a couple of modifications to it. So we have two ways you can basically subscribe to our streaming path. One is I do a select query with rejections where I want you to send me all the traces and logs that match a certain tag or expression or what have you. And again, we can just forward those on as a fire hose for whoever wants to receive those. And with projections, we can even just, collapse it down to a few fields that you care about. And then we also can do analysis queries. So, one of the biggest problems that we have at our scale is like, how do you basically do a graph of showing how many errors for a log, appeared on the dashboard or something? That's quite expensive for us to compute, and especially if we had to do it at query time. But in the streaming path, we can actually do that, pretty simply, because as the logs stream in, we can just keep pushing it over to the subscribers, and the subscribers can start building up a graph that can then be streamed onto whichever other service needs it. So we're using it quite extensively for a lot of our data now. So then I get back to build versus buy. So I showed you earlier on logs, we basically do that per year versus all the other solutions that we looked at. And actually, internally, before that, we were using Elastic. And it's fair to say, had we continued on Elastic, we'd probably be one of the bars closer to the end, kind of thing, just because of the way it indexes and scales and all that kind of stuff. So so how did we get to this kind of cost profile? So we actually have two versions of our log. So this is how we actually started and got this cost down in the first instance. So we actually ended up building a custom solution using S3 and Parquet. And the way it worked is as logs stream in, we have a kind of pipeline that uses Kinesis to pass messages and S3 to pass the data, because you don't want to put the data into Kinesis. But essentially, it would go into the ingester, go to the transformer service that would essentially, do all the normalization, clearing up fields, and just basically adding some fingerprinting and other things that we do there. And then the committer would then push it into a service that we built internally, which is open source, called Iceberg, which is basically a catalog on top of Parquet files in S3. And then we'd push everything into S3 and Parquet. So the storage costs went down massively, especially with Parquet compression. We can store petabytes of data on S3 very, very cost effectively. And then with Iceberg, we can catalog them. And then what we had on the query side is we had PrestoDB, which today is called Trino. And essentially, that was a cluster of nodes that would then use Iceberg to look up which Parquet files to basically search during a query, and then would basically go into S3 and essentially do its parallel kind of scans, and then return the results back to the query API. And this works pretty well. I mean, we're still using some of this stuff today. We're still in the migration to the next version I'm going to show you. Some of the issues, though, were, we kind of traded off cost and latency. So, 2 to 3 seconds isn't that bad most of the time, but it is sluggish. So we did have some complaints from users saying that, when they moved to our centralized logging solution, that they would just find some of the queries, especially for large customers that sent a lot of logs, that they were quite slow in some circumstances. The other thing that we had, because of the way Iceberg works, it would take about 3 to 5 minutes for those logs to appear in the storage. So there were some downsides to this approach. So we ended up basically going down a different path, where we started using ClickHouse as a hot tier. And actually, as we added it as a hot tier, we then realized, actually, why don't we just use it for everything? And Uber's actually been using ClickHouse, I think, for all their logging for quite a while now. So it's got a lot of precedent before us. So we're actually in the path of migrating to this architecture, but this is where we're going to be by the end of this year. But essentially, this has actually ended up being cheaper for us overall, because as you can imagine on the previous slide, I had all these other services. So I had Druid, which I forgot to mention, which is like calculating all the metrics and aggregates on top of logs, like how many errors, how many times did we see this field, that kind of stuff, into Druid, so that we can let people dashboard their logs using our dashboarding solution. So we don't have to get rid of that anymore. We can get rid of that because now ClickHouse provides materialized views, aggregates that we can just basically use on top of ClickHouse. We don't need Iceberg, which runs on Hive tables. We don't need a PrestoDB cluster that concurrency has to run because it's very hard to kind of auto-scale it up and down in real time as queries kind of come and go. So we removed, and we don't need the committer anymore, which writes everything in Parquet. So when you kind of simplify it down, now we can basically push everything within 30 to 45 seconds. It goes into ClickHouse. That becomes our kind of read and write cache on top of S3. And it has S3 support. That's something that he added, I think, in the last year or two. And while we still haven't put all of our data into it for the full 2 weeks that we're trying to do on S3, because once you get into S3, you do get into some latency issues. In general, it's been working really fast, and our query performance has gone really well. So we're big fans of ClickHouse. So that's kind of what we've been doing. And I think, if I was to sum up the kind of two big ideas there, it's streaming and using low-cost object storage where we can to basically store this data, the historic data, as cost-effective as we can. So I want to talk a bit now about where we're going. So in terms of our challenges, these are the kind of things that we need to think about when we think about where do we need to take our platform going forwards. We are expanding to more regions on AWS. We also have way more environments that we need to support, things both inside our VPC and outside our VPC. We also have way more use cases. I'm sure some of you are aware we've launched Live this year. We have gaming, we have ads. Like all of these different use cases have different requirements for how they want to store metrics, logs, and traces. And so we've had to become way more flexible for a whole range of use cases. Machine learning is another one. We do a lot of machine learning, AI stuff internally. They have different requirements for observability. So we've had to basically become more flexible to all these different use cases. We have way more scale. Like as we add in all these new services, live, gaming, more members, all this kind of stuff, our data just keeps going up. And that's not going to stop. It's the same for us as everyone. Data just keeps going up, and our users want more cardinality, which, to be fair, we've kind of limited their ability to do very high cardinality by telling people they have to switch certain things off and things like that. They want more cardinality so they can dive in more into their metrics and logs and traces and get more kind of insights out of them. And more signals. Like we are really kind of supporting metrics, logs, and traces today, but we are thinking about continuous profiling. We're thinking about, NetFlow monitoring. We're thinking about real-time user monitoring, which I think Cliff was talking about earlier. So, how do we add petabytes more data sets to our existing data sets, in a scalable and cost-effective way? And then we also want a more unified UX, because of the history of our team, a lot of our tools have been kind of, somewhat disjointed and siloed and built by one developer over here and all this kind of stuff. We want our platform to be more unified. And for this kind of use case for telemetry, I want to have the same user experience whether I'm querying the last hour of data or a year ago of data. So I don't want to have a disjointed query experience having to kind of get access to my data and do queries and stuff. And again, like our charter, we have to do this in performant, reliable, and cost-effective way. So this is kind of where we think we're going to take the future of telemetry at Netflix. And we're not the first people to call this term. I think we're probably more advanced in terms of how we're thinking about this. But essentially, we want to build an observability data lake. We want everything to be centrally controlled so that different developers across Netflix do not have to think about setting up their own metric solution or their own logging solution. They can just basically set up their service, forward it to us, and it just works. There's nothing else to do kind of thing. We want it to work at petabyte scale. We want it to work in our own VPC. I think Joe talked about this yesterday. Like, one of the reasons we can't use SaaS vendors, it would cost us millions of dollars just to ship the data to a SaaS vendor, let alone pay them 80% margins on top of their more expensive AWS pricing than what we get internally. So it has to run in our own data center. We want to be able to do low query, queries on low latency queries on top of this data, and we want to be able to support a much higher cardinality than we've done before. So we call this the Observability Data Lake because it essentially allows us to put everything into something that we can store it very cheaply, but provide this consistent user experience across the business. The other things we also want to do, we're seeing a lot of demand for business analytics on top of our data. So we want to be able to enable business users to generate business analytics on top of our observability data. So this is why we look at it more of a data lake than just these kind of bespoke solutions for metrics, logs, and traces, and all that kind of stuff. We also would like to do compound queries and alerts where, maybe you can alert triggered off, if the CPU goes up and then my log errors go up, then only send me an alert instead of having these systems kind of all calling from different places. So that's kind of where we're going. And so what I'm going to talk about now is a bunch of the stuff that we are working on, we've been running experiments on. Some of these are quite early. Some of these are things that we're still kind of experimenting on, so I'm not going to say that they're all proven and working yet. But the reason I want to put it out there is because, we're not a vendor. We have nothing to hide. We actually want to work with people in this industry that can bring us great ideas, maybe other vendors, that kind of stuff. So I'm going to put out a bunch of the ideas that we've been thinking about and how we think this could basically be built in an effort to kind of inspire conversation and maybe have conversations with you. I've already spoken to a few vendors here on how maybe we could work together to kind of bring this to reality. So the biggest problem we've always had in observability is, there's CAP theorem, I call it the CSL theorem. It's always been very hard or nigh impossible to basically do low cost at large scale with low latency. You always have to break one of those if you're kind of doing it. So this is the challenge that we've got to solve, especially with an observability data lake. How do we basically bring these three together in a way that we can do it low cost at large scale with low latency? And it turns out actually we already have a solution for that, which actually does match all those criteria, and it's basically doing it in the streaming path. If we were today just to basically forget about historic data and just essentially allow you to start a query from the browser using our LWC service, and then basically just query that stuff as it came in through ingestion using the streaming stuff that I talked about earlier, we could do very high cardinality, very low latency kind of queries and searches and stuff, in the UI. And so at the core of this, it starts with streaming. But then, at some point, you want to look at historic data. You want to look for not just the data that came in since I started that query, but everything that came before that. Maybe for the last hour, typically it's for the last hour or two, but maybe for the last week, 2 weeks, maybe for the last year, who knows. So how do you sort out historic data? Well, ideally we want to put it into low-cost object storage. And this is where we've got a bit of inspiration from companies like Snowflake. There's a few vendors here that are pitching this now and stuff like that. Like, how can you store observability data at scale on S3? Because the challenge is you have this kind of trade-offs. Yes, we can get it super cheap, like hundreds of K per petabyte, and again, that's assuming no discounts on AWS, plus no compression on Parquet. Parquet is actually quite compression efficient. But essentially, we can go all the way from 280K per petabyte, just with list pricing on AWS, all the way to 69 million if we were to store all a petabyte of data in memory. And obviously, we don't want to do it in memory. We do that for metrics, but that's because the metric data set is much smaller than logs and traces. But this EBS one here gets you closer, below 1 million, but that asterisk there kind of tells you that doesn't include the cost of running the instances that have to be attached to the EBS volumes. I didn't bother pricing that in, kind of thing. So this is just the raw cost of having an EBS volume SSD. So ideally, we want to be at that end of, ideally we want to be at that end of the scale. But we have to solve the latency issue. So I think the way we're thinking about it is it really comes down to the catalog and being able to use dynamic compute to basically query that S3 bucket in a very cost-efficient way. So the catalog I'll come back into in a minute. That's basically about reducing fan-outs. But for the lambdas, this is something that we've been experimenting with. Why do I need to have an always-on query cluster? You can use that for like day-to-day queries, but what happens when I want to reduce that query for a very large query that I need more compute for? Well, Lambdas scale up pretty fast. There are some issues with it. They have a very small response payload. So Honeycomb did actually a great talk on this. They're using this internally. But one of the things that they do is they basically write the result when the function finished to S3, and then the query engine then goes and pulls it from S3. That adds a few hundred milliseconds. If you're trying to compress your query latencies, you need to do it faster. So it turns out we've already solved this issue again for Atlas. When we do queries, we actually fan out to thousands of Atlas nodes, and then we open a long polling request, which then streams back all that data, and our query service basically builds up the response in real time as the data streams in, so then we can then stream it back to the user. So why don't we apply that to Lambdas and other parts of this architecture? Like, there is a way to get Lambdas to stream back data as they find rows in the Parquet file, and then just stream back to your query engine, and then maybe you can even stream that to the user. So like in the UI, why do I need to wait for my entire logs to load? I could just basically just start loading the first few logs, show that immediately within less than a second, and even if the rest of the query on S3 takes 5 seconds, 10 seconds, I can just continue loading it below the screen. So we think this has got some very interesting ideas that we're experimenting with. And the catalog is going to be the key thing here. So we've played around with a couple of them. So one of them that I'm going to show a quick demo of if I have time, because I'm running out, is basically a node-based catalog where for trace data, we basically look at all the paths that the traces go through, and we reduce the fan out of that query to basically say for this operation in a GraphQL query, we know it only goes down these paths, and so we reduce the fan out significantly using this node graph-based catalog, which I can talk about offline if anyone wants to talk about it. But the key thing here is it has to be small, fit in memory locally, so we can quickly look up, the index. It has to grow sublinearly with data, and it has to significantly reduce fan outs. The other one that we're looking at is trigram indexes, which MonarchDB made popular. That is a very efficient way of building a very cost-efficient index while also looking up fields and stuff like that. So anyway, this is a query. This is actually an early demo that I recorded before the event of how we're doing this with tracing. So we're starting with tracing because this is where we want to radically expand the amount of trace data that we're storing. So this is actually a 6-hour query. It's doing about 3 terabytes of data in total over that 6 hours, which is about 200,000 Parquet files. And using this graph-based catalog, we're able to filter it down by 3 to 6%. So it significantly reduces the fan out, and that's how we get it down to 1 second latency. And what we're actually doing with this, and it's a very fast demo, so apologies, it goes quite fast because I recorded it too short. But essentially what we're basically doing is we're doing trace-based kind of analysis. So we look at every single trace that matches that query, and then within a second, we're basically getting all the latencies, which services caused the most issues, where the errors, which spans had the most issues. So we're doing all that aggregation across a 6-hour window for all the traces in that period, and essentially bring it up. And this is all coming off S3. So now we're going to another one. So we're getting a lot of early evidence that this is possible. And this is something we want to build on, adding lambdas and a few other things on top of it. So, let's see. So, final thoughts. I guess this is kind of my call to action. So I've been in the industry as a vendor, now I'm at Netflix. We need to commoditize storage. Like I did a talk about 5 years ago on why not to build a time series database. It was the bane of my existence at my last company. Having to build, we went through 3 iterations of it, and it caused a lot of problems. And our engineering efforts didn't go into the end user features; they just went into building this time series database. And I think this is the problem that we're all struggling with. You know, nowadays we have better solutions like ClickHouse. I know a lot of startups are using that today. But at the end of the day, we need to commoditize storage the same way we've commoditized instrumentation using OpenTelemetry. And we want to see that come in, and we think the Observability Data Lake is the way to get to that commoditized storage. And the second thing that I'll just put, Chris is just at the front here. I hope he likes the photo. Basically is, you know, commoditizing storage is not just about being able to do low cost, low latency kind of storage. It's also about every time you migrate from one storage provider to another, at the moment you have to rewrite all your queries and all this kind of stuff because everyone has a different query language. So what we're actually trying to push with Chris's leadership in our team is essentially we've joined the CNCF Tag Observability Working Group, if you guys are interested, to basically come up with a query language that would be a standard for all the storage solutions out there. So we don't have to keep rewriting all alerts and dashboards every single time we try a new queries service. So I feel I've gone over my time, but that's it from me.
Great work. We've got some time for some questions from the audience. We got, here you go. Let it roll.
I have a couple questions. First one is the demo that you just had. Is this using a cloud as a backend?
No.
Okay,
So is the demo you say you're using the
No,
cloud as backend?
this demo is only using custom code, querying Parquet on S3 with this catalog that I spoke about.
Got it. The second question is, you mentioned about from the phase 1 to phase 2, you switch to the house, and I want to know what's the during the migration, and what's your thing that got you, and also you said you ingest about 1.5 petabyte per day, and what's the cost saving in general? I don't need to.
Okay.
So basically, like, what did you learn moving over to ClickHouse? Was that the?
Yeah, so ClickHouse radically simplified the architecture. Like, we don't need the committers, we don't need the Druid clusters anymore, we don't need the PressDB clusters anymore. So we simplified a lot of the infrastructure just moving to ClickHouse. And again, we're still in that migration, by the way. So we still have some of that V1 and V2 kind of running in parallel. But with ClickHouse, it does a lot. I mean, there's a reason Uber uses it. We're now using it. You know, they're outside. You should definitely speak to them. You know, they provide a very performant, cost-effective way of having large amounts of data. So that's why, you know, so in terms of cost reductions, it wasn't cost reductions per se in using ClickHouse, because if we'd, you know, the actual storage, you know, versus what we had previously was probably more expensive, because now we've got to run ClickHouse instances. But because we were able to reduce all the other infrastructure, get rid of the committers, get rid of the PressDB, get rid of, you know, the Druids, servers and stuff like that, and just simplify our architecture, that's where all the cost savings came from.
Okay, good. Thank you.
Any other questions?
Okay. One over there.
Can you talk a bit about what problems you're trying to solve with NetFlow data? Like, why does that need?
What problems are you trying to solve with NetFlow
Oh,
data?
okay. So yeah, so we actually have a team that already does this, but they don't want to do it. They want us to do it, because it's really hard to basically collect that amount of data and get analytics out of it. So, so the reason we do it is, you know, it's the typical things you do for NetFlow monitoring. Not all of our services are instrumented with tracing, so this gives you visibility into what else our service is connecting to. So that helps us with like dependencies and things like that. The other reason is security. Like, you know, so with NetFlow monitoring, you've got you're able to kind of see when you're getting DDoS attacks and see where they're coming from and things like that. It's very high cardinality data, and that's why this other team would like us to inherit it. But if we inherit it, we need to build this observability data lake so we can add another few petabytes of data over here.
Are VPC flow logs included too?
Not sure. I'll have to speak to that.
Okay.
Yeah. Okay, there.
I respect that you can't share actual cost numbers, but I'm curious if you could give a ballpark number of engineers that are on the observability platform.
What's a ballpark number of engineers on
Well,
the
I said at the beginning of the talk, for our team, it's 9 engineers.
Okay.
So yeah, that's pretty much, for all this stuff, the data layer, it's like 9 engineers.
Thanks.
So, yeah. Okay. I don't know, it's quite a few. How about I take some questions offline after this? And
all right.
Yeah.
No, that's perfect.
Okay.
All right, another round of applause. Thank you so much, David.
Thank you.
And yeah, don't forget, we do have those speaker channels. If you have more questions, pop them in there. And also speakers, put your slides in there. People love to see those. And it's a great place. Or just accost them in the hallway. That's fine too. All right, we have a slew of additional sponsors who are going to share more about their amazing products with you. If you haven't had a chance, like I said, to get up there, there's a lot of swag, and I'm going to tell you, these sponsors, they do not want to bring it back home with them at all. So go up there, get some swag, get some socks, get some shirts, all that fun stuff. And
Almost ready?
yeah, just whack that slideshow button, and it should just work. Oh yeah, it's all the way on the. That way. Alrighty, how about a big round of applause for Observe?
Hi everybody, my name is Andrew and I'm from Observe. And we'd like to welcome you to the Observability Cloud. for the very first time, we're bringing together in one single integrated product everything from log analytics to monitoring, dashboarding, distributed tracing, and more. And we're building this platform on a modern cloud-native architecture, which is delivering order of magnitude improvements in economics to our customers. Sorry, I'm having a little difficulty with the... Okay. So let's talk about what Observe is and how it works. Observe works by ingesting from commodity, open source collectors and agents. It treats everything as an event, and it retains it for 13 months. We then shape these events post-ingest into real-world things. Pods, containers, lambdas, users, what have you. We call these resources, and we correlate them together into what we call the data graph. The data graph represents the entire universe of all your telemetry, and it's contextually linked together. Finally, we provide opinionated, curated experiences in the form of data apps. These are pre-built dashboards, alerts, logs, and metrics, giving DevOps and SRE teams everything they need to perform their investigations and bring MTTR and MTTD down. What's really cool and special about the data lake is there's no complex data tiering. Forget the days of doing complicated hot, warm, cold architectures. Forget rehydrating from archival storage. The Observe architecture is fundamentally different. Observe stores all your data in an S3 data lake, and then intelligently accelerates that data into a Snowflake data warehouse. This simple, highly scalable architecture is what allows us to achieve significant economies of scale and significantly reduce the cost to our customers over what they're spending on legacy observability tools. And this architecture is built for scaling the demands of tomorrow. Already, our largest customer is ingesting 300 terabytes a day into the Observe platform. This allows them to do things that before they had no possibility of doing. For example, by joining and correlating their AWS VPC flow logs to customer actions on their mobile devices. Oh, and by the way, all your data is stored for 13 months standard. We don't drop data on the floor. We don't require you to put it into Glacier for long-term retention. It's all there. It's all available 13 months or longer as you need it. So the data lake is completely agnostic with respect to how you ingest. You can use any open source commodity collector of your choice, whether that be Prometheus, Elastic FileBeat or MetricBeat, AWS Kinesis, Datadog Agent, OpenTelemetry, and more. It's even trivial to onboard your cloud assets using our standard integrations to onboard things like AWS Lambda functions and any flavor of managed Kubernetes, EKS, GKE, AKS. We don't believe in using proprietary agents. We rely 100% on open source commodity collectors. Okay. The true power of the Observe Data Lake isn't just that we can ingest any type of data and store it for 13 months, but rather how we shape and relate your data in contextually meaningful ways, and we call this the data graph. In a nutshell, we build a connected graph of all your data sets. This allows you to clearly see how, for instance, a signal from your Kubernetes pod metrics relates to application container logs, which in turn is informed by your OpenTelemetry traces, which may be impacted by developer commits and your CI/CD pipelines. And we do all of this using schema on demand. There are no complex or rigid schemas to manage. Data is ingested as is, then shaped, parsed, and correlated on demand post-ingest. Now, as you know, current application architectures are highly ephemeral and getting more complex over time. And the complex interplay between microservices, serverless functions, pods, containers, and CI/CD pipelines means that any observability platform must also be able to understand the state of your system at any point in the past. And this is exactly what we've built on Observe. To support this, we've developed a temporal relational query language that allows you to ask point-in-time questions about the state of your architecture at any point in the past. And finally...
This is my creepily being like,
oh, am I done?
I'm the hook.
You're the hook? Can I have one more slide?
One last thing.
Thanks. Finally, we've integrated large language model support into the platform. So you can ask Ollie GPT, our online assistant, how to get things done in the platform, and very quickly it will turn around actionable code snippets, which you can copy paste right into the code builder, the query editor, and get results immediately. Thank you so much. Come join us at our booth upstairs.
Awesome, thank you, Observe. All right, our next sponsor is from Victoria Metrics. Let's give a big round of applause for Victoria Metrics. I'm always impressed with people who have Linux on the desktop because it's a harrowing exercise to extend a monitor out there, but when you get it working and you run the right commands, it's the year. This is the year. Just you gotta, guys, he's got to run a system D command to restart something. Monitor D.
It was working before I tried.
Oh wait, hold on. Your browser's capturing that thing. We actually tested this before because let's be honest, it's Linux.
Yes.
Keep it on the server, people.
Let me try another way.
So, for those that don't know, this is a beautiful scene of Pacific Northwest. Not really. This is a show. Oh man, I'm blanking on the show now. Oh, we have a different laptop. Midsummer's Day. So as of yesterday, when I asked the crew, and they can maybe wave if there's still tickets available. I think it's Wednesday night. I see a wave. Yeah. Yeah, so if you are interested, I've actually seen a show here after Monitorama before. It's really fantastic. They do an amazing job. So if you are still in town on Wednesday and want to enjoy some wonderful theater, highly recommend it. I believe you can just go to the box office or maybe buy online. Looks good, so definitely recommend that. All right.
So.
And then, yeah, this is like, because Macs suck ass too, so. If you haven't known, I really just hate all computers.
What do you like?
Smoked meats is what I like. I'm a suburban. I don't know where to get to your Chrome with the things.
People who are late for interviews because they've been smoking.
Exactly. I have an IoT. I am a Luddite, and I don't have anything IoT connected because that's ridiculous. Except my smoker, which I had to set up a completely dedicated Wi-Fi connection to because I didn't want to literally get hacked because of my smoker. Although if I did, it'd make a really good conference talk. So, all right, let's give a big round of applause for Victoria Metric.
Yeah, today I'll talk about why you are doing logs wrong. The most of you probably use Elasticsearch for logs, and let's look at the typical screenshot of Elasticsearch UI. It looks pretty good, yeah. Then ask yourself why you need all this stuff around the UI, and ask yourself what is the most important on this UI. And this is only this one line which is shown in the bottom left. Probably Grafana Loki is better. Let's look at the Grafana Loki screenshot. Yes, it's better. It shows 2 lines of useful information instead of 1 line. And Grafana Loki is known for its very complicated query language for humans, typical humans. If you use Grafana Loki, you feel me. I think you know what I mean. And what is the proper solution then? The proper solution from my perspective is to integrate your login system with command line tools such as grep, less, head, and so on. And both Elasticsearch and Grafana Loki, while they provide some HTTP APIs, and these APIs can be curled, and Grafana Loki also provides command line tool, but that's not enough. Let's look at another solution, which is named Victoria Logs. The following screenshots show a sample how Victoria Logs can be integrated with existing command line tools. This screenshot shows how to send a query to Victoria Logs and then pipe it to head and instantly get useful information, useful logs which you are looking for, and start investigating them. And it can be improved further by using JQ and selecting only the message field you want. And the concentration of useful information jumped to 100% in this case. Just look at this information and investigate it. You can also refine your query just by pressing up key and in your console and change this query as you investigate issues or logs. You can also pipe the query results to less command and investigate the full response despite of the size of this response. The size of the response can be terabytes, and you can still put it into less and start investigating streamed logs instantly instead of waiting for hours until these logs will be processed on the logs system. And also you can calculate arbitrary complex statistics of logs with usual command line tools as you do with local logs, locally stored logs in the same way. And of course you can store logs into files for further processing. I put stored logs to dev null in this case, but you can store in regular files and then process these logs. Yep. So try Victoria Logs and try this command line integration and share the word about Victoria Logs. I mean. And of course, Victoria Logs also provides quite good query language, which is named LogSQL. Also follow this link and read the tutorial of LogSQL and try using it. And tomorrow, Victoria Metrics will host a lunch at Shake Shack. This 2 blocks away from here. So come to our booth at the 2nd floor and talk with us.
Thank you so much. Appreciate it. And sorry, the Linux dinner, all the Linux people are just very sad right now because that did not work. It's all right. Next year, it's another year. Come on up, we'll get you plugged in. All right, let's give a big round of applause for Sumo Logic.
Well, I'm short compared to everyone else. I had to pull this down. Hi, everybody. I'm here from Sumo. We are a continuous intelligence platform product. We basically take in logs, metrics, traces, events, and then we correlate and analyze that data for all of you guys. So who am I? I'm nobody, but like really, they just let me on stage. I don't know why. I have over a decade of domain expertise and experience in engineering, product management, product marketing. I like gardening, reading, hanging out with my dog and my turtle. I work on a bunch of cool side projects. Some of them are open source, some of them are not. Here's a slide on why unified collection analytics matters. So here's what happens when you don't have unified collection and analytics. You have someone who can see only one part of the picture, but then someone else sees a different part of the picture and comes to a different conclusion, and they might not be wrong. You know, as far as this person knows, it is a rope. As far as the first person knows, that was a spear. But as you kind of start to unravel the whole picture, you start to see that it's an elephant. And what's beautiful about unified collection and analytics is that you can do in-depth analysis. If there is something wrong, in your system as an IT manager or as someone who's a security analyst, you can actually kind of see the whole big picture. And that's kind of what we're hearing a lot from customers and what we're hearing from a lot of practitioners. So how can they consolidate observability tools so that they don't have, one provider for metrics, Sumo for logs, et cetera? What do they need in order to use, let's say, more than one collector for different types of telemetry data, logs, metrics, traces? They don't want to be limited by vendor lock-in or tech lock-in. If they want to, let's say, consolidate, like the onboarding process for us can be really fragmented. How can they speed up their troubleshooting for a critical issue popping up at 3 a.m.? Depends on who you're talking to, right? So this is why Sumo Logic loves OpenTelemetry and why we've made a huge investment into it. Why should it sort of matter to you? Well, it helps sort of break down IT silos with unified collection on fewer agents. People hate working on a bunch of different agents and having a bunch of like proprietary technology or having vendor lock-in. If they are stuck with one agent, they have to stay with said agent for forever. Sometimes it's just technology lock-in. For us, we have also found that for our OTel collector, it's very highly performant. I think that it kind of allows for easier onboarding. We also have made a lot of really good contributions to OpenTelemetry, so upstream to languages for Go, Kubernetes tracing, JavaScript, and PHP. PHP doesn't have a link yet because that one's brand new. And then we also support other ones like Istio, Java, .NET, Python, Ruby on Rails. We're also fully OTel native. I also wrote a book on navigating Kubernetes monitoring. You can check it out if you're interested. If you want to maybe peek behind the door for someone who's been in the space for a little while. All the way from its humble open source beginnings to market dominance or ubiquity. If you want to check out the Sumo Logic product, you can stop by our booth and we can give you a little demo over at booth C. You can kind of see what it's like to start monitoring on your application in minutes. Also, don't miss our Observapalooza event tonight at Hunt and Gather. We're going to be sort of co-sponsoring the event with Shoreline, and you can also catch Kentic there. And I'm going to get the hook soon, so see you.
All right, thank you. Thank you so much, Sumo Logic. Great to have all these amazing sponsors, again, supporting this conference. It really makes it what it is to have these conversations and to sponsor these parties tonight. So there's a Slack channel is Tuesday Night Lights. There is a listing of all the sponsors are in there. Shout out to whoever put the map in there. That was awesome. So yay community team for just solving the problems here. And then for any other events that people have, I know I'm already starting to see other people put some of their other events in there as well. So if you're looking for something to do, there's plenty of fun activities. So I know all of the Linux people were really sad before because we had a bit of a Linux snafu, but that's all right. We've got a second chance here to reclaim glory. Is that what you wanted to happen? I mean, we're almost there, but here. Okay, it worked. Let's clap. Linux, awesome. Oh, and Google Slides work too. It's amazing.
There you go.
I love it. All right. Well, let's give a big round of applause to Tony.
Hello, everyone. My name is Tony Rippey. I work on storage systems, not monitoring, at a company called Two Sigma, which is a hedge fund in New York. I apologize in advance because I'm going to subject you to yet another histogram talk. I've been working on a project that I'm pretty excited about, and I hope you'll find it interesting as well. Now, that hedge fund also employs lots of lawyers, and they say I need to include a disclaimer in my slides, so feel free to pause the video and read that, but we're going to move on. So this is our starting point. It's a graph from my laptop. It's looking at CPU usage. And all of us together, we've collectively probably spent years of our lives staring at graphs like this. Maybe you're trying to understand how your system behaves, or maybe you're looking for behavior that's out of the ordinary. But either way, there's a common problem here, and that there's not enough data. Like, despite the data that's being shown there, the data that you're seeing is actually altered in some way. These are cumulative metrics that are being sampled on a regular interval, and that sampling is typically things like a second or a couple of seconds, which can actually smooth over the data and hide interesting features. What you'd really like to be able to do is collect as much data as you can and get high resolution data, but that strains not only the infrastructure, your monitoring infrastructure, but also your wallet. Depending on what services that you use, high frequency information can get very expensive quickly. Now, this isn't a new problem, and there are solutions to that, and it's histograms. Histograms are a way of collecting high-resolution samples in the client, aggregating them, and then storing efficient summaries on the server at far less cost. It works by bin counting, so you take the range of possible values that you're observing, and you break it up into buckets. And rather than storing the raw samples, you just store the count of the number of samples that fall into each bucket. And then when collected, you can use those to display things like heat maps and bar charts like you see here. And this is way better than an individual time series. I find this far more useful. But still, there's some problems here. Histograms are collected on time intervals, and those time intervals tend to be long. They're usually a minute or 5 minutes or even up to an hour in some cases. And when you collect those long intervals, it can actually hide useful events that happen on smaller time frequencies. So that's not great. And the reason why you store them on such longer intervals is because they're expensive. Even though histograms are orders of magnitude cheaper than storing the raw data itself, it's still very expensive when compared to just normal gauge metrics. And so you tend to spread that out as a way of saving space. Also, if you're trying to, you need even more histograms, because if what you're looking for is behavior that's out of the ordinary, then you need to scale out and look at longer time horizons and to see what looks normal. And you have to usually figure that out with either arcane knowledge of your system or pattern matching to be able to understand what looks normal and what isn't. Ideally, I would like to have a graph that looks something like this. And it's two distributions. The first one is the time period you're looking at. That's represented by the yellow. And a blue one, which is some sort of a baseline that somehow tells you what to expect of your system, what normal behavior looks like. Now, not only am I going to argue, can you make this graph, but I'm going to say that you can make this graph and save a ton of disk space while you're doing it. Now, here's where I'm going with this. I don't have a lot of time. It's only 30 minutes. And so I'm going to cover 3 main points. The first one is measuring the accuracy of histograms. The second one is how to take histograms and group them by similarity. And then third, I'm going to show that you can use that grouping of histograms to create a representative histogram that you can store at far less cost. All right? Some disclaimers about this. This is a fun project I do on the side. I'm no stats guy, so I might be getting some of this wrong or incorrect in places. Please let me know. And also, this is an experimental setup. This is not a working production system yet. I would love to get it to the point where we can use it. We don't use it at Two Sigma, but that is a goal of mine. Okay, histograms aren't the only form of aggregation that you can use. There are simple things like averages and standard deviation, and there's more complex things like the summary type in Prometheus, which is the T-digest that several people have mentioned now in this conference. And when you say histograms, that's not one thing. There's actually many different types of histograms. I'm not going to go into these. I have links in the slides, so if you want to read about them, you can always look at them later. Instead, I'm going to focus on a bigger idea, which is aggregations are all approximations. And this is something that I don't think people think about too often. When you summarize data, something is lost along the way. And you should look at, well, how accurate are these histograms, and how do you measure that? This is the first thing I'm going to dig into. Luckily, histograms, all of the different types, work by bin counting. And bin counting has its properties that you can represent it by a unified representation under the covers called a CDF. Now, CDF stands for Cumulative Distribution Functions, and I'm obsessed with CDFs. Now, I suspect that not everybody shares my obsession, so I'm going to go into what those actually are. Most people are familiar with probability distributions, or the bell curve or the Gaussian curve that we have here. This is actually a probability density function, and what it tells you is that when you evaluate this function at a value of x, it tells you the relative likelihood that that value will be pulled from a random sample. CDFs are similar. They actually are a different view on the same data. Instead of telling you a particular value, the relative likelihood of a particular value, it tells you what's the likelihood that that value or less will be drawn from a random sample. And there's a mathematical relation between them. A CDF is actually the integral of a PDF. Now there's a special kind of CDF called an empirical distribution. This is a CDF that's built from a set of samples that you collect. And the way you do that is you count how many times you've seen a particular value, and then you do a cumulative count of all the values sorted, and then you scale that by the number of samples that you collect, and that creates a CDF. And what you see here is that it ends up looking like a step case function here, right? And if that algorithm for creating this sounds familiar, well, it's bin counting. It's the same sort of thing that you do when constructing a histogram. And in fact, you can take any histogram and create any CDF from it by using the upper bound of a bucket and the number of items in that as the count of the values. Now in reality, histograms use some sort of interpolation across the bucket. So the graph, a CDF of a histogram would look slightly different than this. I'm going to leave it as the staircase function because it's a little bit easier to kind of understand what's going on. Now, when we want to measure the accuracy of a histogram, here's what I'm going to do. I'm going to create two eCDFs. The first one is going to be from the raw data. Now, in a real system, that's too expensive to keep around. You can't just keep all the raw data available. But in an experimental setup, you can totally do this. So I'm going to create an eCDF from the raw samples that are collected, and then I'm going to create a second eCDF from the histogram itself. And to measure the accuracy of the histogram, I'm going to look at the difference between these two functions. Now, there's multiple ways you can do that. And to understand the differences, I'm going to look at the different ways that Prometheus gives you to inspect histograms. The first way is a function called histogram fraction. And what that tells you is how many of the samples come between an upper and lower bound. Now, upper and lower in this case are the units of measurement of whatever you're looking at. So if it's latency, it's going to be a unit of time. If it's, say, the donuts eaten in Portland, it's going to be a raw count. So the value you get back is called a rank. And it tells you where the data that you've selected lies relative to all the other data. You can think of it as kind of like a percentage, but it's called a rank. And luckily, this rank is independent of the data. It's on a scale of 0 to 1, no matter whether you're looking at latency or you're looking at disk usage. It's the same values. The error, but it's important to emphasize that this is an approximation still. It's an estimate of what the actual rank is. And as you can see here, like there is a difference between the raw samples and the histogram. And this difference is called rank error. And if you look at a lot of studies around the accuracy of histograms, this is mostly what they call out. And also the Kolmogorov-Smirnov test, the KS test, is also based on rank error. The second way that you can measure error is histogram quantile in Prometheus. And in this one, you give it a percentile. So you can say something like, give me the 99th percentile latency here. And that's a parameter Q into this. And that will return you a value where roughly, how it estimates that 99% of the values are less than or equal to that value. And this also is an estimate. It's not accurate. There's going to be a difference between the 99th percentile of the underlying population and the number it gives you. And that's called value error. If anyone has read the DD sketch paper, which is another type of histogram, the thing that they're optimizing for is relative value error and trying to minimize that. Or actually put it within known bounds. All right, what I did for my experiment, though, was something different. I actually looked at the area between the two graphs. And if you think about it, it's actually a product of the value error and the rank error combined. And so I like it for that. It includes both kinds of errors. But also, I like it because it helps me pass the eyeball test here. If you minimize the difference between the two graphs, then when plotted on a dashboard, it's going to look similar. and hopefully convey similar information to the user, the human who's actually staring at the dashboard. And so I thought this might be a good, useful measure of difference or error. So now that we've talked about how to measure that, I get to the second big idea, that histograms are actually a form of lossy compression. You have a whole set of data that compresses down into this compressed form of bin counts, and you're compressing these things. And anytime this is just like an image, like encoding as a JPEG, right? Some information is lost, but you can still see the image. And when you're accepting lossy compression, that means you're willing to accept some error. You have an error budget. And anytime you have a budget, you're like, how can I spend it best to get the most out of it, right? So one question I was asking myself is there any other kind of compression that we could fit into that error budget? And I would like to propose one such method, which is the clustering of histograms. Clustering, for those who aren't familiar, is a set of taking objects. Now this is objects in the mathematical sense. It can be anything. It can be a number. It can be a color. It can be a unit of time. In this case, the objects that we care about are actually histograms. That's kind of a weird thing to wrap your head around, but bear with me for a minute. So you take these objects and you divide them up into groups. And what you try and do is you want to make sure that any of the objects that are in a group are as similar to each other as possible. And so how do you tell whether they're similar? Well, we just did that by measuring the accuracy of histograms. So we're going to look for ones that have the smallest difference between them and count that as similar histograms. So once you have all those pieces in place, then you actually need to group them. And there's lots of different ways to do that. I've listed some of the common ways up here. Again, feel free to look at the slides later for more info. I experimented with several different approaches with this, and I ended up using a modified version of dbScan, which is one of the simpler clustering algorithms. And I'm going to walk through how that works. So here I'm representing the histograms as dots on a 2D plane. It doesn't actually look like this. I couldn't figure out a good way to visualize histograms flying all around. But the way that the algorithm works is you pick some sort of random starting point. It doesn't really matter where you start. It ends up with roughly the same result. But you pick a starting point. And there's one parameter into the dbScan algorithm, which is epsilon. And epsilon is a measure of how far apart items in the cluster can be and still be in the same cluster. Now, this is going to be a distance in terms of the error that we're talking about, the area difference between the two graphs. And unfortunately, this depends on the data. If you're measuring things like donuts eaten, it's going to be relatively small. But if you're measuring something like bytes read from disk, this epsilon might be really big. So this is a parameter that needs to be tuned to the data. That's kind of one of the weaknesses of this approach. Anyway, so once you have this epsilon, you look for any points that are within epsilon radius of the starting point. And then you do that again. You add those to the clusters and start again and again until you run out of neighbors. There are no more points within epsilon of the available points in the cluster. And then you pick another random point and start again until all the other points have been assigned to a cluster, right? Once you have the clusters, you have to calculate something called a centroid. Now, a centroid is a really fancy math term for a midpoint, right? Where's the middle of this group? They don't call it a midpoint because typically the things that you're clustering aren't spatial. They don't map cleanly to coordinate systems. But the way that we're doing it here, you have a group of histograms. The easiest way to create a midpoint is to merge them all together. It's the histogram merge operation. You take all the bins and all the counts from the different histograms and combine it into one big combined histogram. And that ends up being roughly similar enough in nature to the rest of them to act as a centroid. And once we have those centroids, the important step here is that you use that centroid as the value for those histograms you collected. That means you only need to store the centroid. You don't need to store the individual histograms that were collected from the client. Think of this like a database schema. So before you do this clustering, you have a time series, and you store it in something like this table, where this table grows linearly with time. And the value that you store in the time series is the histogram, which can be quite large. After the clustering, you replace the histogram with a foreign key that points to a set of known clusters. And that foreign key is going to be around the same storage characteristics as a gauge metric, right? It's as cheap as a gauge. Meanwhile, you do have to store the centroid once as a histogram in this table, and it's still many bytes, but you're putting it in a table that has bounded growth. And I will get back to that, I promise. But first we need to cover one thing, which is this is a monitoring system. It's easy enough to run a clustering algorithm on one batch of data, but you have new data that's arriving all the time, so it needs to work on a stream of histograms. And the way that I do that is that you have some sort of a working set in a batch that you collect. And there's one modification to the clustering algorithm here, which is when a point comes in, you check it first against all the other known clusters. And if it's within epsilon of one of the existing centroids, you map that to that cluster immediately. Otherwise, you run the algorithm as you would. OK, now I mentioned that the growth of the clusters is bounded. And this is non-intuitive, right? But try to imagine the set of all possible behaviors of your system as a 2D plane here. All these blue circles are the clusters that you've seen, which represent observed behavior, right? And the blank space between these are behaviors that you haven't observed yet, right? When a new data point comes in, if it happens to lie within an existing cluster, then great. It's assigned to that cluster and then nothing changes. But if it lands outside the cluster, then what this means is that it will eventually become a new cluster and take up some area of epsilon around the available space. And over time, you'll get more and more that fall outside the bounds, and there'll be more and more and more clusters added. And as time goes on, it becomes more and more likely that existing data or new data that comes in will be mapped to an existing cluster. All right, enough of the theory. Let's try this in practice. I ran a series of experiments. I pulled up a bunch of public monitoring data sets that people have published in the past. And I ran through these scenarios and measured very carefully of the results. The first thing I looked at is convergence, like how quickly does it go to a bounded number of clusters? Oh, sorry. No, I should talk about the data I'm using. The first data set I looked at was Bjorn Rappenstein from Grafana Labs. And he published a bunch of data for testing of histograms from Cortex and gesture logs. That's a collection of monitoring data. There was a lot of data here, but unfortunately it was only 2 minutes worth, which wasn't enough time to really see convergence. So I didn't use this data set, but instead, luckily he published a second data set, which was the query logs. And that gave an hour's worth of data, and so I used this as the initial data set. When I mapped how many clusters were being generated over time, I was a little disappointed with this, right? So what I did is I did multiple runs through the data with increasing amounts of epsilon, which means you're accepting more and more error as you go. And I expected to see fairly rapid convergence, but here it looks almost like straight lines, right? I promise you that it is curving. It is converging very slowly over time. And this is a little bit of a problem because if it converges too slowly, then at the end you end up with an unwieldy number of clusters, which can slow your algorithm down. But as you increase epsilon, then it does converge faster. The next thing I looked at is how many samples are mapped to clusters. And in this case, you see a big spike at the front. That means one of these clusters got a huge proportion of the samples mapped to it. This is actually great news because that would be our baseline. That's our baseline behavior of the system. And it serves as a useful purpose for that. And then everything else, there's this very long tail that you can't even see on the graph that goes all the way out. Those are the interesting behaviors that you would want to compare against the baseline. So this is actually very promising for my ideal graph I was looking at before. All right, so the next thing I wanted to look at was the most important bits, which is how accurate is this clustering and how much disk space can you save with it, right? Before I get into the results of that, I do want to talk about that measurement. Because if you take a step back, what we're doing is we have a set of raw data, and then we're using that to build a histogram. And then we're taking the histograms, and then we're combining those into clusters. Now, there's error introduced at every one of those steps. So intuitively, you think that these errors are going to compound and get worse and worse over time. But what I'm actually measuring is fidelity to the raw data, to the underlying data set. So I'm measuring the accuracy of the histograms relative to the raw data and the accuracy of the cluster to the raw data. And this is important because I had suspected that the error introduced from the histogram might actually get canceled out somewhat in the clustering. I don't know how many people have heard the term that a sum of errors is less than an error of a sum. That's what I suspected was going on here. And in fact, the results do show that. This graph is a measure of cluster accuracy as compared to the original histogram. This 1 over the 0 on the left is the original histogram and the error involved with that, across all the samples that were collected. And the orange line is the average as it goes. The units on the side, a value of 1 means that the cluster has the same error as the histogram. A value of 3 means that it has 3 times the error of the histogram. And that sounds terrible. That sounds pretty scary. But actually, this is fairly good news. Because what it shows is, first of all, even as you accept larger and larger amounts of error, the average error of the clusters are still within 1 standard deviation of the histogram itself. And that's pretty exciting. But even more exciting is as you increase the amount of error, epsilon goes up, the error grows slower. This is the canceling out of error that I was talking about. So this is sublinear growth on the error over time. Now, when you compare that to the disk savings you get by doing this, oh, what happened? Okay, when you compare this to the disk savings that you get by doing this, disk savings actually grow faster than the amount of error it grows. It's superlinear growth. And this is great because that means this is an effective lossy compression technique. You can make a reasoned trade-off of space versus accuracy with this. And at this point, I was feeling really good about this work, but I wasn't done yet. I had other data sets. The other one was fairly high number of requests per second, and I decided to look at a lower QPS data set to see how it behaved. This is one published from an online web store. It saw similar behavior in that it had sublinear growth of error over time, but the disk savings went way down. And this kind of surprised me. Like before, I was converging towards 80% disk savings, and this is just a little over 50%. What happened? And I dug into it, and I eventually figured it out. And what this is Amdahl's law. So basically, what you're doing to save this space is replacing a histogram with a foreign key, right? If that histogram were the same size as the foreign key, then you wouldn't save anything at all, right? But if the histogram is really big, you're going to save a lot. And what was actually happening here? Oh, and so you can actually map out this behavior. So if you know how big the histogram is, you can calculate a theoretical limit of how much disk space you could ever save, you can possibly save. And that's what this graph represents. So the size of the histogram over, and then how much disk space that you save. And if you look at the data sets I was just looking at, the medium QPS data set, it has more requests per second, which means it's packing more samples into the histogram, and the histogram is bigger. In the low QPS data set, you're packing fewer samples into the histogram, so it's smaller, but that also reduces your potential savings. If you then go back and then put a line that shows the theoretical limit of how much you could save, what you're really seeing is that as error increases, the disk savings slowly approach the theoretical limit. I wasn't done yet. I had one more data set. That was all request logs and latency. I wanted to try it on something completely different. So I scraped proc stat on my laptop for a week, and I used that as a data set of CPU utilization. And when I crunched numbers and ran a simulation on that, I saw very similar behavior. The error grows sublinearly over time, and the disk savings behaved similarly to what you did with the low QPS data set. This one is even lower because there were still fewer samples per second from the web logs. So, the interesting note about the CPU data, though, is that the clusters converged really quickly. I suspect because there's less variance in the data. Like my laptop sits idle most of the time, and so like everything gets bundled up into the things in the low end of the usage spectrum. All right. Overall, I'm pretty happy with the results. Even in the worst case, I saved like half the disk space for storing this. I was able to store a week's worth of high-resolution CPU samples in less than 2 megabytes, which I view as a win. Now, this has problems. It's not all roses. So some of these problems are endemic to histograms in general, and one of them is sampling. I mentioned that you collect them on time intervals, right? Well, those time intervals matter. Like this is a hypothetical example. You have some sort of event, and your latency spikes and goes way up and then goes back to normal, right? And if your sampling looks like this, then you can clearly see an anomaly, right? You'll have 2 histograms that show normal behavior, and then one in the middle like, oh gosh, this is an outlier. There's something weird going on here. But if instead you split it down the middle, then it's not as clear. And the histogram can actually make it harder to see whether there's a spike. So this is something you have to be careful about. And so I would advocate, since you have a good compression, to use much smaller histograms or smaller time intervals. Some of the other challenges with this is that this whole accuracy versus space trade-off probably does not make sense for business metrics, right? So if you have things like KPIs or SLOs, you should probably collect that there's some other method like the T-digests. There's also, the way I use to measure accuracy depends on having the raw data. That doesn't make any sense at all in a production system. You can't, like the whole reason you're doing this is to avoid keeping all the raw data. So I really don't have a good way of monitoring like how the accuracy in a real live running system, which isn't great. And then finally, the last thing is that histograms aren't free. You're doing more processing on the client to be able to generate these histograms. And if you have an application that has a really tight CPU budget, this will cause you to use more resources. So it's worth keeping in mind. There's lots of future enhancements to work on this with. For one, I'm working right now on trying to find good ways of tuning and finding that epsilon parameter automatically from the data. I definitely want to ship a working collector that can do this on live production monitoring data, and so I don't have to work with synthetic or known data sets and be able to collect that. I was hoping to have my ideal dashboard. I have all the data, but I didn't get the dashboard together in time, but I was hoping to present that today and didn't get to it. But then finally, be able to have the dashboard support and then running queries against this data. But I would love to hear what you have to say. I have the Slack channel. Please put comments in the Slack channel. I would like to know if you find this is useful. Is this something worth pursuing? Grab me later and let's talk about it. And if anybody is interested, you can take a look at the source code. It's all up on GitHub on the project Mumble under my name. And I will be posting the slides later for all the links. Thank you very much.
That's really, really fascinating stuff. I love it. And, you know, Linux on the desktop.
Linux on the desktop.
We're here. We made it, people. Who has some questions? Questions from the audience? Oh, thank you.
How did you generate that kind of known world of histograms? Was it just by varying bin size or some other variables? Like, as you were showing that slide with the clustering,
Yep.
how did you generate all the histograms to start clustering?
So how did you generate all those histograms?
Very good question. So I had the data set that is in CSV form. And I just created an app that used the Prometheus libraries. And I ran through the CSV, dumped it into the Prometheus libraries to generate the histogram, and then saved that off as a protobuf, and then went from there. Does that answer the question, or were you asking something different?
Maybe I'm not familiar enough with Prometheus. I'm just curious to know, yeah, like, what did you vary in order to generate the various representations, the various histograms? I can find you later.
Okay, yes. Let's catch up later.
Yeah, right here in the middle here.
Yep.
Yeah, so some really interesting ideas there. Can you talk a little bit about what you would build on top of this? Like could you do alerting based upon deviation from the baseline, or like what are your thoughts there on what you build on this?
Yeah, what are your thoughts on where you go from here?
That is a very good question. I was mostly approaching this from the angle of just saving space, but this could be very useful for things like anomaly detection. I suspect that there's probably better anomaly detection techniques out there because some of those, like I showed the big baseline that has most of the samples, and there's a long tail, but it's probably the case that some of those in the long tail are totally fine, right? They just don't happen to map to the baseline itself. So I'm not sure how useful it would be for alerting. I do think it can make an interesting dashboard for like visually seeing where there might be different behavior. Like what I was hoping to do is put up a dashboard of like a calendar or a time frame where the intensity of values, where you can see the bright spots are things that are very different from the baseline, and kind of like smaller grades of color that show you things that are closer, closer or further away from the baseline, as a way of being able to hone in for where there was odd behavior happening. So it was mostly for digging in and inspecting data, or at least that's the way I've been approaching it so far.
Awesome. All right, we're a few minutes behind, so we're going to use this break to get back on track. So we'll reconvene in here at 3:45 in the back, snacks and coffee and drinks and all that fun stuff. Another big round of applause for Tony. Thank you so much. This is great. Hopefully snack was good. Not brownies, what was it? Like some sort of chocolate pretzel thing, right? Yeah? I'm very excited to go out there and load up on some delicious snacks now that you're going to be all back in here. So we've got 2 more amazing talks to close out day 2. And I know I say this like about pretty much every single talk. I'm really excited about this talk because we're going to talk about Mastodon, which obviously kind of exploded into the world in kind of broad appeal around the time that the hell site, bird site, got even more hell site? I don't know. Got even more terrible?
It went from being the bad place to becoming the bad place.
the much worse place. So yeah, so I was really excited to see this talk in the proposals because I think this is a really a fascinating topic, a really relevant topic, and yeah, really excited to see it. So let's give a warm welcome to Hazel.
Hey everyone. My name is Hazel Weekly, and I am the infrastructure witch of Hackaderm. And I'm really excited to be talking to you about a whole bunch of cool stuff and maybe some monitoring. So the agenda is, you're probably wondering why we needed monitoring for Mastodon, why we needed monitoring for Hackaderm. Okay, and we did actually need something. Let's talk about that. Maybe let's talk about why we chose what we did, and then how it helped, how it didn't, what we could do next, where it's going on, and then asterisk, some philosophy, musings about life, what is monitoring even for, all the good basic questions like that. So why we needed to, let's actually wind back to November of 2022. It was a glorious time, and by glorious I mean terrible. And Elon Musk had just become even more Elon. Everyone knew he was terrible, but now everyone actually knew he was terrible. And so a lot of people left and decided to go somewhere else. And they went all into everywhere on Mastodon, including Chris Nova's basement, quite literally at the time. And so the first week in November, we were like, okay, we have some monitoring. Second week in November, we're like, it's a good thing we had it. We definitely needed it. The third week in November was about 30,000 users, and we were beyond screwed, no hope, absolutely nothing can save you. And then fast forward, we had kind of solved some of the large major incidents of Hackaderm. Things are a bit more stable, and we're like, now that we've added all the monitoring that we didn't think we had, that we do actually have, we've done the other 80%, right? And then fast forward to February, and we're like, you know what, this whole monitoring thing, no, we don't have it. No. So to even jump back before that first week in November, we knew when we started Hackaderm that we would need something. So we're like, okay, cool. None of us know how to operate Mastodon whatsoever. Have you tried looking at the documentation for how to monitor and observe and actually run Hackaderm or Mastodon at scale? And it turns out that you can't find it because it's not in the documentation. They just kind of assume it's not a problem that you have or care about, which is fair and reasonable, except for when it's not. And then so we're like, okay, scratch that. Mastodon's actually just a Rails app, right? Everyone loves Rails, super easy to run in production, very easy to scale. Yes. So we're like, all right, so how do you monitor and observe a Rails application when you don't own the code? And it turns out it's difficult. There are vendors out there. You can sell your kidney to them. You can say oh, black box observability, they will give you something that pretends to do that. And sometimes it does actually do that. But when you can't really modify the software you're running, it's a hard question. It's not really, you're not really doing that, right? And all of these have one big thing in common, which is they're spendy. They're really, really spendy. they really assume you have more money than sense. And we didn't have sense, but we also didn't have money. So we're like, all right, let's step back and look even deeper. What happens, and how do you monitor Rails when you don't run and own the code, and also you don't have money? You give up. Straight up, you give up, right? And so everyone's like, okay. The real answer is no one's ever got fired for starting up and using Prometheus and Grafana, right? So you just wire it up, eat that in there, and you're like, you've solved observability, you've solved monitoring, you've solved everything, right? Absolutely not. It turns out that we have this world, this foundation of open source software, decades and centuries of human-driven development to the collaborative ecosystem. And actually making that be a collaborative ecosystem with capitalism involved is really difficult because capitalism. All right, but we did pick Grafana, we did pick Prometheus. Why did we pick those? Well, so actually, what is monitoring anyway? Monitoring is a verb much in the same way that watching TV is exercise. So when we say you monitor something, you just stare at it really closely and do nothing. But back up your storage bow. If you want to understand your system, that's a different question. If you want to interact with it and answer questions, that's a different thing. But monitoring is not really actionable. It is a verb, it's an activity, but so is golfing, and that one doesn't really contribute to society. So what are your needs when you're trying to observe something? I think you can break it down to kind of 3 different things. You need to understand your relationship to the system, what type of questions, what level of understanding you need to have with it in order to form a hypothesis of its behavior over time, and what feedback loop and what speed do you need to be able to evolve your understanding of the system. So let's look at this like cute little chart with the word maturity in quotes, because I am a person who is very immature, and I don't think that maturity is like a thing to actually strive for, but here we are. Thank you, Garter. So we have systems, relationship, hypothesis, sophistication, the feedback loop, and what type of, quote, observability kind of fits there. Step 1 is proto, which is like you're not even started, right? But your relationship to the system is that it's a service, and you just kind of purchased it. You paid them a bunch of money, and it's not your problem. So you open a support ticket. Anything wrong with it, you open a support ticket. How long does it take to close it? I don't know. Have you seen like pull request times on GitHub? Like, The next level would be the kind of emerging level of your understanding of a system. You're running this off the shelf. You're able to ask these true-false questions of like, is it on? Is it working? Is it there? Your feedback loop of that system is going to be in kind of like the days level. And that's where monitoring really kind of fits. It gives you those true-false questions. It gives you that level of understanding of a system. And if that's all you need from it, it'll fit really well. Competent would be like the service operator. This is where everyone in the industry is kind of trying to like centralize you on, because you have this like first order logic. You want to ask questions of not just, is it on, but does this thing do something meaningful for these person, like this user, for this whatever. You have a subject, you have an action, you have a verb, you have almost a full last sentence, except you don't have punctuation. So that's where tracing really fits in. And that's where that like really rapid feedback loop starts to come in. And I actually think this is the one with the fastest feedback loop possible. Because a platform starts to get into You can't have a fast feedback loop on a platform, because if you try to innovate too fast, you're going to end up deprecating everything, and everyone's just going to think you're Google. So you do have the opportunity to have higher order logic when you're thinking about trying to build a platform and you're trying to provide that to people. And so this is the last one, and it is the system creator. And my somewhat spicy opinion here is I don't think anyone is at this level yet. Like, as a species, we don't understand what it takes and what it means to build a socio-technical system and actually like do that. Don't actually know if we have a long enough lifespan right now to get to this level. But it's a cool level, right? You feel like you want to get there, but it requires reinventing politics, and no one actually wants to do that. And then once you have your understanding of your relationship to the software, there's kind of these different aspects of where you might need that observability and what sort of level you might need it. You have the user, you have the software, you have the machine, and you have the network. There's a couple others, but for Hackaderm, let's focus on these four. So for Hackaderm, for users of Hackaderm, we were their SaaS. We were, you just log in, and it works. Unless it's between the days of November 19 and December 3, in which case, kind of. But hey, you all survived, we survived, made for a great story, it's fine. For software, we were operating Mastodon off the shelf, and this is probably the most conscientious and controversial decision that we made in Hackaderm. We were trying to do this in a way that, to go back here for a second. Off the shelf, true false questions, feedback loop days, what were we really trying to do there? We were trying to solve the question of what does it take to build a service, to build a community that is owned by the community. And when you do that, you need to actually take the health of the community and the community's ability to contribute back into it into account. So think about a community garden, for example. If you have a community garden, you don't set that garden up with a bunch of drones, like drip feeders, and like electronics, and like a whole bunch of over-engineered nonsense that no one but you can operate. That's not a community garden, that's your personal space that you dumped in the community. If the community itself can't contribute to the operating, and like to itself, and like actually work together with you, it's not really a community. And we were trying really, really hard to avoid being yet another system of yet another overlords, but this time we're cuter. Which is true, but we were trying to avoid being the other people. So going back into that. And then we had the machine and the network, we were operating those as a service. But we were trying to answer the question of what does it mean to be a community, and to build a community together in which part of it is the software, is why we did the operating off the shelf with Mastodon. We purposefully used the upstream software. We did not fork it, we did not patch it, we did not run it on Kubernetes, because we were trying to make it accessible to everyone. And not auto-scaling Sidekick is a choice. We survived it, but it's a choice. So fault domains are kind of like one of the other sort of aspects of helping you figure out, in my opinion, what level of monitoring, what level of system hypotheses do you need for your system. And here's how that works. You have this really nice, non-understandable diagram of Mastodon and how it works. You've got the file system, you've got the Redis, you've got the Postgres, you've got the Sidekick, all the things, service, whatever. And the idea is that you draw a little box around things and you go, when this thing fails, here's kind of the blast radius. And that can help you think about what type of hypothesis do I need to form in order to understand the system, in order to build it and improve it. And that will let you know kind of what it means to monitor that system, to understand it over time, to develop it, to make it more resilient. So I actually sat down and tried to design a little like section of vault domains for Mastodon, and I think I did a pretty good job. So if you look here, this is what the road of good intentions looks like, and somewhere in the auto-scaling is of Sidekick is what we will call, quote, hell. But this is the road of good intentions. And this is a very, very similar fault domain setup as basically every other Rails app, which, you know, is why like Twitter had its fail whale, Mastodon had all of its fail whales. We had me posting random stuff and trying to fix things at 3 in the morning. You know, it's tricky. It's really, really tricky to untangle a system and think about the fault domains and being able to actually separate it out, particularly when it has evolved organically over 15 years. So that's kind of where Mastodon's at. That's where Hackaderm is at. If you want to reinvent Mastodon from scratch, you are more than welcome to. You can get the same exact diagram in Golang. I guarantee it, it is possible. We call it Kubernetes. Sorry, what? So you're probably wondering how monitoring helped Hackaderm during all of its incidents and how it didn't. So it did give us a ton of visibility. That wasn't actually the biggest issue a lot of the time. Like, and I'm saying this as someone who spent, 4 days diagnosing an epic failure that ended up being, quote, because of 2 failing hard drives. Visibility was not the issue. It was what's visible, where's the understanding coming from, what types of questions can you actually solve about it. It did help us diagnose issues faster, but the issues, the ultimate causes of a bunch of things, those are never clearly exposed. And root causes are in quotes because root causes are fake, and fake news, terrible, horrible concept, but they're useful for illustrating the point. So we did actually take advantage of it being relatively out of the box for a lot of the monitoring, despite the fact that we did actually have to end up writing our own exporter anyway, so it turns out it wasn't out of the box. But for the first 24 hours, we thought it was out of the box, and that was really nice. So how it actually did end up helping the most, we had Sidekick monitored cluster-wide to kind of get like that trailing indicator of how screwed you are. Seeing CPU load was crucial in understanding the balance of the system load, and visibility into the RAM tended to be pretty useful in the beginning. And what it didn't help with was disk data was not actually helpful for us, and it should have been the most helpful thing. As I said before, one of our biggest incidents was because of 2 failing hard drives. We did have monitoring the metrics on the hard drives, on the drives, the whole time. So much for that. Streaming is still a giant black box of use. Like, we have no idea how it works, why it's designed the way it is, and how you can make it this inefficient. I swear, it pays an entire computer and a half. No reason for that. And the alerts were almost entirely useless. We're going to get into that one. So here are some of the outages, some of the factors, contributing factors on what we missed. And so, like, ideally, we would have taken what we missed, made more alerts, gotten better monitoring, and, like, prevented the problem from ever happening again. Because that's always possible. Or not. So we had the big one, which had the 2 hard drives failing. If we had disk performance monitoring, maybe somehow that could have helped us diagnose that way faster. We had December 13, 504 timeouts, and that was a full file system on the database. Whoopsies. So you can have alerts for that. Media caching was a misconfigured cache setting. Not sure how you get monitor alerts for that one, but feel free to tell me. Queue latency was queue priority misconfiguration, a lack of compute power. How do you ask the question, are my queues misconfigured? And get an answer from a quote monitoring setup. Or December 20, the queues in Queueville. All these outages, by the way, correspond to a blog in the Community Hackathon website. So if you want to read the incident report for all these, we have them all there. So suboptimal balancing and parameter tweaking is the reason why this one happened. How do you monitor that? Like, well, what does that even mean? We had another one was expired SSL certificates, quote, temporary instability, subtle understanding the edges of the system, expired certs, bad method of renewal, and you're starting to see, so let's go and look at some of the trends to notice. One is, very quickly, we reached the limits of what you can actually understand, quote, monitoring. All those questions that we have back there are things like, you don't have a sensible way to monitor that. That's a question with nuance, and you can't get that from monitoring. And half of those you don't really have from the system as you can even instrument it right now. Remediating problems as another trend so that they don't happen again is really, really hard. It turns out that centralizing the knowledge so that the fixes can happen faster is way more effective. Humans and human slack in the system is a superpower. Never underestimate it. Facilitate as much as possible. Don't let the humans be the only source of stability of the system, but take advantage of them. Like, document the fixes so that they can actually happen again. Like SSL certs, by the third time we fucked it up, we were so good. We were so good at fixing that. We fixed that shit in like 5 minutes. But should we have had to fix it 3 times? I don't know. It took 2 minutes to document it. It would have taken like 20 hours to automate it. You know, think about that. So what's next? It would be great to have better monitoring for the streaming service. Spoiler alert, what will actually be nice is for someone to upstream one of the Golang rewrites of the streaming service. I know of at least 2. Please upstream them. It would be great. We could use them. It might actually suck less. But also, put some instrumentation in that. Please. Another thing that might be useful for us going forward in monitoring is uptime as a concept is nebulous and wrong, but maybe we could be a little less wrong about it. And, you know, having alerts that are actually useful would be pretty neat. It would be probably the only thing you actually use monitoring for now that I think about it. So, we have monitoring. And hopefully we have something you can actually use with the monitoring. But in the meantime, we have monitoring. And there is a slide that I forgot to put in there that says Q&A. Thank you very much.
We've got time for some questions. Are there any questions from the audience? Any questions from the top? All right. Oh, they're coming in fast and furious. We're gonna do one right down low.
So you had a thing about question marks on the cache misconfig, which probably is difficult to monitor config versus misconfig. And I'm assuming, were you monitoring for cache hits versus misses, and is that how you noticed the issue?
Were you monitoring for cache hits versus misses?
Caches what?
Were you monitoring for cache hits versus misses, and is that how you identify the problem?
We had the data somewhere for cache hits and cache misses. It's a very nebulous concept. Really, a lot of our stuff with the cache problem, so let me go back to the cache problem. The cache problem here was, anyway, so the problem with the caches ended up being due to like 6 different things going wrong at once. So cache hits versus cache misses wouldn't have actually helped us anywhere. It was like, are these file paths being rewritten by some gnarly nonsense in the Ruby code base or not? And if they are, how do you migrate things on the fly while having things in S3, things in a different object storage, things on a local file system, which is in NFS, and things on a different file system, which are not in NFS? And one of those 12 different scenarios may be right and 4 of them may be right at the same time.
I think there was another one down here. Was there? Or no? There was definitely one back here. Maybe? Yep.
Yeah, I was curious if you had any thoughts or pointers about how to be less wrong about uptime.
How to be less wrong about uptime? How to be less wrong about uptime.
So uptime is a concept that you use in order to figure out how much money you're going to give to someone else when you fail to meet it. Which is to say that it's bullshit made up in order to sell money to other people. Uptime is like health, which is like correctness, which is a fully human concept of something that hides a whole bunch of implementation details that are actually kind of but not really relevant. So for a distributed system, like Hackaderm or just Mastodon in general, nothing is fully up. At any one point in time, something is kind of sort of maybe down. But for you, you log in and it works, and so it's up. But we could have a different way of being like more accurate about it rather than just the home page returns 504, which I think is what we test for. And things like notifications don't work. It is actually kind of important.
All right, let's do one more, I think, right here.
Since you made a big point of trying to make this like a community garden and take stuff off the shelf, do you intend and have you contributed some of the monitoring things you found back up?
Yeah, have you contributed back up to the Mastodon open source?
We have contributed back up to Mastodon a little bit. We haven't actually patched a whole bunch of code and then contributed up. We have convinced other people to do that, which is kind of the same thing. So one of them in particular was during an incident with Hackaderm. We had this issue where our database was slow as balls, and consequently, we were hitting these massive timeouts that were causing cascading retries in the back end, and that was causing duplicate posts to be all over the place. And so someone upstreamed a patch that prevented that issue by waiting for the timeout and then not retrying in certain cases, which ended up breaking some web apps in a different way, but in a less wrong way, most of the time.
Awesome. So we'll move any additional questions. Remember, we have the Slack speaker channel, as well as after at the in the networking area, as well as at the events later tonight. So another big round of applause for Hazel. This was fantastic. Really enjoyed this. So as much as we would have loved to have this last speaker physically in person, COVID is unfortunately still a thing, and he caught it, sadly. And so he's doing well, although he'll tell you that, I guess, when we get his audio connected. But he was still feeling up to, still presenting his talk, which we're really excited for. We were able to zoom him in here, and Leon, you're actually on the screen now, so you can give a quick wave. Make sure that you can hear me. Oh, cool, then that's the confirmation he can hear me. And just give me a thumbs up if you're ready, because I don't actually know if you are yet. Okay, beautiful. All right, so our next speaker is Leon. Give it up for him and his thousands of miles away talk on Zoom.
Thank you very much.
Let's
first time
actually, yeah, real quick. Sorry, Natalie. Can you audio the thingy? All right, and Leon, can you talk?
Audio the thingy. Yeah. This is a technical conference, you can tell.
What? We're gonna unplug. All right, we have unplugged and replugged.
Have we audioed the thingy yet?
It's a lot.
We're still audioing the thingy.
This is framework laptop.
We'll just drink tea until the audio is thingy.
Feedback? We actually did test this before, interestingly enough. We clearly did not test it well. It's actually Windows. Shut. Thank you for the music.
But like it's gonna shut off if I don't plug it in.
I can start.
Powered on the other side.
Have we audioed the thingy yet?
Oh man.
It's gonna be my new phrase. Whenever we're setting stuff up.
All right.
Audio the thingy.
Yeah.
Pete can put that on his, how do you pronounce video series.
Okay, you're on, Leon. Can you hear me? Oh, you're muted. Okay, you've got it. Except it's gonna be you're in a race against time because we can't power the laptop. Oh my God, we're getting messages from Jason's wife.
How much time do I have?
So it's a framework laptop. There's no way of knowing.
Amazing. Okay. All right. All right. Are you ready? All right.
We're as ready as we'll ever be. So, all right, let's give it a big round of applause to Leon.
Thank you. It is amazing to be speaking at Monitorama again, second year in a row, sort of, again in this weird post-pandemic, but not really situation. So I'm really grateful to Jason and Pete, and I don't want to use up my battery time with all that stuff, but all gratitude. So I really appreciate it. All right, so a few years ago, I was tweaking a new alert rule, and I accidentally cut 772 tickets twice in 15 minutes. And the worst part about it was I didn't even know I had done it until the entire help desk showed up at my cubicle and invited me down to their area to help them close the 1,544 tickets with them. And with a little bit of time and experience and some alcohol, and therapy, I can reflect on this formative event and sort of think back to what the problem was. Like, whose fault was it? Was it the tool? Was it the operator? I think there's enough blame to go around, but in a larger sense, I think it was an immature philosophy about what an alert actually is. So I want to thank you for sticking around at the end of this day for my talk. Alerts don't suck. Your alerts suck. My name is Leon Adato. I'm a middle-aged white dude giving a conference talk. What else do you need to know about me? I've been working in tech for 35 years. I've been focused on monitoring and observability for 25 of those years. I've used a whole host of tools from Tivoli and Nagios and OpenView all the way through SolarWinds and janky Perl scripts and, of course, New Relic. I've built systems for small, medium, and ludicrously sized organizations and really spent a lot of time digging into what makes monitoring observability and especially alerts tick. I also picked that picture so you have absolute confidence that I know what the hell I'm talking about. But more important, I want you to understand that this is an oyster talk. What I mean is that I've got 30 minutes, maybe less, depending on how long the battery lasts. And in that amount of time, I can't teach you anything. About the only thing I can do in that time is irritate you. Now, when an oyster gets irritated, it does one of two things. It creates a pearl, or it dies. Now, I sincerely hope I do not irritate you to death, but you have been forewarned. Instead, what I hope is that I give you just the grain of an idea that you will then layer over with your own ideas and experiences until what you have is something that is polished and unique and valuable to you. Okay, so the SRE handbook defines alerts as, I'm reading off the screen, a notification intended to be read by a human that is pushed to a system such as a bug or a ticket queue, an email alias, or a pager. Now, not to blaspheme the Holy Scripture or anything, but what the FSCK am I supposed to do with that? I mean, how does that make me feel like alerts are anything except useless and pointless? And that's because the SRE handbook has failed to explain what the value of an alert is. And ultimately, that's what my talk today is about, is how to make alerts valuable. Now, if you remember nothing else from this talk, I want you to have these first two takeaways. I put them right up front for you. The first one is that inbox rules to handle your email alerts are like assholes. Everyone has one and they all stink. What I mean by that is that if you have an email rule to handle your incoming alert messages, you've already admitted defeat. You have stated unequivocally that you have no intent to actually deal with the alert at all, ever, and certainly not right now. And for an alert, the only valid time to respond is right now. And I'll get more into that in a minute, but that's the first takeaway. The second takeaway is that I'd like to welcome you to this hill that I'm willing to die on, which is that FYI alerts are trash. All right? I don't understand the concept of why people would want FYI. And I've heard the excuses. I've heard people say, oh, no, I don't do anything with the first alert, but after I see the alert 4 or 5 times in 15 minutes, then I know it's really something I have to deal with. You know what? I don't get paid by the bushel for these things, so how about I just count up when the event occurs 4 or 5 times in 15 minutes, and I send you one message, and you know to deal with it then. Really, there's no such thing as an FYI alert, and anyway, I'm willing to fight anyone who says otherwise. Okay, again, the point of this talk is that alerts need to have value, and I'm going to share the why and the how over the next 5 lessons or so. And the first lesson is on the fundamental nature of what alerts are and aren't. So let's get started. There are 3 important rules to remember. The first one is that alerts are not the same thing as monitoring. And the second one is that alerts are not monitoring. And the third rule is that alerts are absolutely not the same thing as monitoring. Monitoring is nothing more and nothing less than the ongoing, steady, regular collection of data and metrics and information from a set of targets. That's it. Everything else, alerts, but also dashboards and reports and all the rest of it, those are happy byproducts that you get as long as you do the first thing. You know, as long as you do the monitoring, by all means, collect all the data you want. Monitor the crap out of your stuff. I don't care. But alerts should be biased toward action. That's what they're supposed to do. So you're going to obviously monitor a lot more data than you're ever going to alert on, and that's okay. That's how it's supposed to work, in fact. So let me give you an example. Every year, your boss comes back from Monitorama with a new pair of socks and a shiny new observability tool, right? And the first thing you do after you unwrap that sucker, the observability tool, not the socks, after you unwrap that, is you create a high CPU alert, because everyone does that. And I have a secret for you. High CPU alerts are bullshit. Really. High CPU isn't a problem. It was never a problem. If an application is running consistently at 98%, but all the jobs are getting done and all the processes are complete, you know what I call that? Correctly sized. That's what that is. Okay. At this moment, you're probably thinking, oh, he's going to oversimplify everything down to CPU and RAM and disk and bandwidth, and he's going to ignore the lived reality that we all have of dealing with a metric ass ton of metrics and events and logs and traces on a daily basis. Because what Leon is talking about is that old school monitoring, and what we deal with is the new shiny observability. I see this happen a lot. I see conversations about alerts get stuck on the point of monitoring versus observability, and it's an inherently false argument. It was never monitoring versus observability. So let me flesh out some of the important nuances here. Now, I'm about to draw a line on the slide, and I do so with the absolute respect and gratitude for everyone who fought and was wounded in the observability flame wars on Twitter over the last few years. Okay, the examples I'm giving, the nuances I'm pulling out are for the purposes of alerting only. So even though I'm not there, I really don't want to find out that Charity Majors has hunted me down and is going to now rip out my intestines. Okay, so also for those of you who are trying to fill out your observability bingo card, here we go, you're welcome. Observability, again, for the purposes of alerting, has a few aspects that matter. The first one is that it's focused on the unknown unknowns, right? I don't know what could go wrong, and I don't know when it could go wrong, or any of that stuff. It also focuses on events that have high cardinality, meaning they're really unique. Not just unique in a specific element, but also in the combination of elements. So that metric ass ton of data we talked about, all those data points together, and the different combinations and permutations, that's also unique and high cardinality. That's an aspect of observability. Also, because of that, it tends to have correlation baked into it, because it's too hard to sort of think about, or again, what Charity would talk about is reason about all those data points individually. And finally, it focuses on the golden signals. All right, the signals that tend to be true about poor or great performance, irrespective of the application of the source, the fundamental elements behind it. Now, monitoring, on the other hand, deals a lot with the known unknowns. All right, I know this stuff is going to break, I just don't know when. Okay, whether it's hardware or software or a combination of the two or whatever it is, I know this stuff tends to break, and I just want to know what happens. Also, all cardinalities are important. All cardinalities matter in the sense that if something is really common, I still need to know about it, because it still has value to the organization to know when it broke and what we can do about it. The correlation, therefore, often is manual, because again, it tends to be more specific and common, and so I can reason about it more readily, and so I tend to put the correlation together myself. And finally, it's domain-specific signals, meaning that the signals that matter to a particular set of hardware or an application type or whatever are unique and don't relate back to other hardware or application types. So those are some nuances, and the reason why I pull those out is that if we look at just the observability side of that line, okay, high cardinality events, especially high cardinality events that are derived from a large set of disparate data points, how are you going to alert on that? Well, there's really only one way to get there, and that's to let the computers do the work. Now, at this point, the marketing folks are going to jump on the stage and say, yes, we're going to use AI, and we're going to have ChatGPT, which is the preferred way of pronouncing it according to Corey Quinn. ChatGPT, and we're going to do all this stuff. And the trouble with saying AI is that we all understand that it is a bullshit marketing term for 3 if statements in a trench coat. Now, joking aside, you can see, though, with all of those aspects, again, that high cardinality, a lot of data points, how it would be challenging to talk about alerts in that context. I'm not saying that all of the thoughts that I'm sharing today on alerts don't apply to observability systems and solutions, because they do. It's just challenging to give detailed examples without keeping you all here past the next happy hour. So that's why my examples tend to be a little bit more simple for the time being. All right, back on track. Lesson 3, alerts have to matter. To you, of course. Of course they have to matter. But more importantly, to whoever's getting them. Now, what do I mean when I say that alerts have to matter? Well, there's a simple algorithm to understand if this alert has been built to matter. All right? If and only if, all these conditions must be true. If the intent of the alert is to get a person to do something about it right now, about a problem that is happening right now, if those things are true, it's an alert. Otherwise, it's not. That's just how it works. Alerts are biased toward action and a bias toward immediate action. Otherwise, there's something else. So naturally, you're asking yourself, okay, well, what's the something else that they're supposed to be? All right, let me break that down. If it's not involving a human, what you're talking about is automation, and I will talk more about that in a minute. If it's not supposed to be dealt with right now, what you're dealing with is a report. If it's not dealing with a problem, then what you're talking about is probably a dashboard, just a place where information is happening. And this one's most important. If no one is going to do anything about it, no one is going to do something, delete it. It serves no purpose. It's the same thing as those FYI alerts, all right? If no one's going to do something about it, you are wasting cycles, you're wasting workload, you're wasting processing power, because it doesn't actually have any value. Get rid of it. Now, there are 3 common pitfalls to creating alerts that matter, and the first is the trigger condition itself. So let me go back to that CPU alert I mentioned earlier. As I said, high CPU alert, high CPU by itself, not a problem, correctly sized. However, if I have high CPU and also there are more jobs in the processor queue than I have CPUs on the system to handle it, and that situation is lasting longer than a particular period of time, now I have 2 things. I have something very different from just high CPU, it's more than 80%, wow. Like, no, all right? But more than that, I know what to do about that. CPU is high, more jobs in the CPU queue than the processor queue than I have CPUs to manage. Now I know it. I'm going to elastic compute my way up so I have more CPUs. I'm going to reduce the number of jobs. I can do things about this. And that's a very different situation than what I described earlier. And our goal as people developing alerts that don't suck is to think about how do I build this in a way that indicates what action should be taken, that I'm taking all of that into account. Another issue, another pitfall, is that it's not the triggers necessarily, but it's the time frame. Now, everyone looks at this graph, which I got from Leon Fayer. And if you have a chance to hear either one of the Leons, you want to talk to Leon Fayer. He's the superior Leon in every context. In any case, everyone looks at this graph, and they say they know exactly what to alert them. They can see the problem. It's right there, staring in the face, right? But that spike might be completely normal. That might be end-of-month processing, or it might be elastic compute, realizing that you're running at a really low rate, and so it just drops a bunch of systems. And so now it appears to go high because relatively it's running hotter, but it's really because there are fewer systems involved or whatever it is, okay? What we all miss, all of us, is that spike. It's the exact same amount. It's also 4,000. But our human brains aren't designed to detect that because it's occurring over such a long period of time. This is what monitoring and observability solutions are built for. And this is what we should be thinking about alerting about. Not just that rise. It's not always one thing, right? But it's this rise in conjunction with other elements. And this comes out of the fact that we have to prize and include and normalize time as one of the fundamental aspects of our alert triggers. So the third trap is having a lack of automation. So again, simple example, I know. When the disk is full, we all do the same thing. We are all going to do exactly the same thing. We're going to clear the temp queue, the temp directory. That's what we're going to do. We're going to clear out those temp drives, and we're going to blow the disk away and rebuild it or whatever, but we're going to clear it out. Now, the question is, if that's what we do every single time, why not have the computer do it for you? And as a proof, I implemented this at one company, and that one piece of automation, ridiculously simple and simplistic, right? That cut 3,000 tickets a month out of the number of tickets that were being thrown to the help desk. 3,000 tickets. It also represented $8,000 of staff time. that didn't occur anymore because they're just automatically being taken care of. Because we clear the temp queue, and if the problem goes away, we go back to bed. That's it. If the problem persists, now that's another problem. And that gets us into more about automation. See, one of the most powerful aspects of alerts is that they are witness to the exact moment when a problem occurs. Nothing can be more effective than having the right response at exactly the right moment. So a lot of folks will skip over automation, though, because they think it's hard, or they don't know where to start, or they're not quite sure what to do, and they don't know how to figure out what to do because the alert itself is sometimes complicated. And the truth is that figuring out what automation you need is really easy. All you have to do is find the person who's getting that alert right now, today, and ask them this question. When something goes wrong, when you get this alert, what do you do about it? They're probably going to say something like, oh, yeah, I typed the gafrinkle command, and then I see what happens after that. Okay? Oh, well, how about I have the computer type the gafrinkle command for you, and then I'll let you know what happens. Like, that's what automation is all about. Having that conversation allows you to find out what the workflow is and to be able to insert yourself into that. Now, the really cool part about this is that those conversations will lead to really interesting automation routines that are both effective and also comprehensible. They're not necessarily the fanciest or the most difficult to code, but they are really powerful. You know, for example, again, slightly simplistic example. I've got an application running on an IIS server and it's running slow. All right, that's what I detected. So what's the first thing we do when something on IIS is running slow? We clear the application pool. We always do that. It's just what you do. And then you wait. And if the problem doesn't go away, then you restart the IIS service because that's what you do. And then you wait a minute, 2, 3, whatever it is. And if the problem doesn't go away, then you rebuild the image or you restart the server, depending on what kind of environment you're in or whatever. And you wait and you see what happens. And if that doesn't work, then you vMotion or you move to a new region or whatever it is. And then you wait. And if that doesn't, now you send a ticket because I'm all out of options. I don't have anything else I can try. But the really interesting thing to look at with that kind of flow is that when a human gets the ticket, they know that those things have already been done. And hopefully they get the output from all of those commands so that they know the result of all of those actions. And now they can step in with their human brain and they can start to think about, well, okay, that didn't work, that didn't work, that didn't work, so now what could it be? All right, you have helped them leap ahead in time along the way. But where do you get those steps? All right, if you have a lot of experience in tech, then maybe you know about this, but you don't have to be that person. What you have to do is ask that question, is ask, you know, when you see this problem, what do you do about it? And just keep working on it. And as you learn more, the automation grows and that process flow continues. All right, and that leads to probably the most important lesson of all. Talking to people nicely, nicely. Nobody at your company is a psychopathic, homicidal clown. Probably, I hope. But you talk with them with the same determination of the world's greatest detective hunting down the real killer of my app 123. What I mean by that is that the only way you're going to understand how critical an application or an issue is, the only way you're going to understand how much someone cares about the performance of a particular system is to talk with them and to get that context. And that puts you into the hunt for the great useful alert. Okay? I say hunt because you need to find the recipient of the alert, not the requester. And you're usually going to talk to the requester first. And I got news for you. They lie all the time. They lie to you because to you, for the requester of the alert, you are just a checkbox on their way to pushing the prod. Did you hit an alert? Yes, I did. Ha, ha, ha. Moving on. No, you know, they're going to say, no problems here. We've built this baby like a steel rock made of angel farts and unicorn spit. It's going to work fine. They're going to lie to you, all right? You need to get to the person who's living with the system day by day. Now, these are the questions that have helped me zero in on what really matters about this once you find that person. First of all, how do you know when something went wrong? Okay? Not okay, the users are calling me or the VP is threatening to fire me or whatever it is. But like when you jump on the system and you look at this and you type like a Frinkle command or whatever, it's like, oh, now I know there's a problem. That's going to give you an indication of what triggers you're going to need. How do you know that it's all better? You know, this is important and something that we don't consider a lot is that, yeah, there's the trigger for when the problem occurs, but sometimes you have something that's sawtoothing. And that means that, you know, it's not better, it's just back. And you want to know what better looks like so that you can put that into the system as well. Is there a knowledge base article for this? Yet. Because if there isn't, there needs to be. I will not roll an alert into production unless there is a knowledge base article, because some poor slob is going to get this message at 2 o'clock in the morning, and if there's no anything that indicates what they should be doing about it, I'm not doing that to somebody. And so we're going to build the knowledge article. Even if the knowledge article says, yeah, call Bob. Like, okay, poor Bob. But, you know, hopefully there's something better than that. But there has to be a knowledge article about it. And finally, make that thing happen, that problem happen on purpose. If you can't make it happen on purpose, you don't understand the problem well enough yet. You don't know what the cause, and that means that your trigger actions aren't going to be correct either. Now, obviously, there are cases when you don't want to do this, right? Like, you know, if you have an alert that tells you when the data center is on fire, obviously don't make that happen. But obviously, there's ways to deal with that, of course. Okay. A little bit of a bonus round because everyone's like, you know, won't ChatGPT save me from all of this? Now, I am not saying that AI is garbage and it can't possibly work. My experience is that large language models are effectively calculators. And what I mean by that is if I'm balancing my checkbook and I use the square root function, something is horribly wrong, either with my finances or my ability to do math. Having a calculator doesn't make me do it better because I don't know what the hell I'm doing. Having ChatGPT or an AI, you know, tool doesn't help me if I don't know anything about it. I have to be able to ask the right questions in the right way. And if I do that, then AI is an amazing asset. But if I don't do that, if I can't do that, then it's going to be really hard. Oh, okay, I have to pause.
Hi, Leon. How are you doing?
Hi, I'm doing great. How are you?
So I had a little notice on my laptop that says I need to upgrade to Zoom Pro. So I've done that on my phone, but it doesn't seem to recognize that on the laptop. So if you could give me just a second to maybe Alt-Tab out.
Not a problem.
Thank you.
This is great.
You won't see this at a KubeCon, will you?
Welcome to Monitorama, folks, where anything can happen.
What you missed was Jason furiously purchasing Zoom from his mobile device backstage. Yeah, just yeah. No, you already bought it. He actually already bought it. So, where's the? Yeah, it's.
The thing is that I don't think it kicks in if you're already on a call.
Yeah, that's what I was afraid of.
All right,
hey, Leon, can we log out really quick?
Yeah.
And log back in, and we'll meet you up. Thank you.
All right. Yeah, just.
Right. I mean, I guess we didn't technically need to purchase it, but
well,
why am I not the host? Oh, because I've got to join with. So, it's it's. What are you doing? No, it's Zoom, man. All right.
The Zoom employees in the audience like crouched down lower.
Sorry, I've got to jump over to Google Calendar really quick so I can rejoin this.
Why don't you? Why? This is like explaining to my mom how to do this.
Okay. Did you let him know to join up again?
Oh. Is it the same link?
Yes.
He's gonna be like, what link? The link doesn't work.
He's in and waiting. Awesome. There he is.
Oh, yeah, there we go.
Hey!
We are consummate professionals here, Leon.
This is amazing. No, really, this is host disabled screen sharing. Give me my screen sharing back, man.
There you go.
All right, let's see. There we go. All right. And share. And there we are. Delightful. Okay.
Thank you, Leon.
Keep going?
Yes,
No
sir.
problem.
All yours.
Thank you to everyone in the audience for enjoying that. This is like, look, man, you don't see you see things at Monitorama that you'll never see anywhere else. That's the truth. All right, let's bring this one home. All right, so like I said, I'm not saying that AI is garbage. It can't possibly work. I tend to, when people say ChatGPT, I tend to think calculator. We talked about my inability to balance a checkbook. If you can ask the right questions in the right way, AI models can be incredibly, useful and amazing assets. The trouble is that I think we'll all agree that not all of our users have that level of domain knowledge and understanding to be able to ask those questions with that level of specificity. And that's where things can go off the rails in terms of, will AI remove all this toil? It won't unless all of our users have a level of knowledge that's kind of a little higher. And I want to give you a non-technical example. We've read about ones where, like, the lawyer got fake rules, and the other day somebody asked ChatGPT if, how many prime numbers end in 2, and it said there were 5 of them or something like that. Like, we've all seen those examples. I'm going to use one from actually my tradition in Orthodox Judaism. There's actually an AI model called there's an AI model called Rebbe.io, and they fed basically all of Scripture into it. They fed the Torah, they fed prophets, Psalms, Song of Songs, all of it, and also 2,711 pages of Talmud, along with all the commentary from the sages going basically back to Mount Sinai. Like everything. And so you have all Jewish knowledge, all the wisdom in there. And then we asked a question, is turkey kosher? And the answer we got back, and I'm going to read this to you just so you can understand how interesting the failure is. Okay, it says, turkey is not considered kosher according to Torah sources. Okay, the Torah specifies that only certain animals are considered kosher, and turkey is not one of them. The criteria for an animal to be considered kosher include having split hooves and chewing its cud for mammals, or having fins and scales for fish. While turkey does have split hooves, it does not chew its cud, and therefore it is not considered kosher. It's important to consult with a qualified rabbi or kashrut authority for specific guidance on what foods are. Okay, you can see how incredible this is in that all those sentences make sense, but it's like an alien who's never actually seen a turkey has been writing it. All right? And that's with all the information from all of Scripture fed into it. And it made that mistake. So when we're talking about, will AI and large language model tools be able to help us when we've fed into it all of our monitoring data? The answer to that is, well, yeah, but you have to ask the question just right, and you have to understand the information that you're getting back to make sure that it jibes with reality. And when we're talking about observability with high cardinality events and a metric ass ton of data, I think that also brings to bear the question of, can you know if you're not getting accurate information? That's a thing. By the way, I did take that answer and I fed it into DALL-E to find out what this animal, this kosher turkey, would look like, and so it drew one for me, which was kind of cool. All right. So let me wrap this up. We have identified and interviewed the recipient to find out what matters to them and what's important. We've designed an alert that matters because it uses real-world triggers, and it takes the duration of the issue into account, and it includes automation, and it has been verified. We've verified that the alert is built with the intent for immediate human action. We've done all the things. What's left? So this takes me to my final lesson. It's the shortest, but it's also the biggest burden on you. Once you've set up an alert for someone, even if that's yourself, you can just forget it, right? Like, it's set up and it's done. You can walk away. It's going to be perfect forever. No. You need to go back regularly as part of your process. You need to go, whether it's once a quarter or every 6 months, and you need to see how that alert is fair. You need to ask the recipients, is this working for you? You need to find out, is the alert triggering too much? Is it triggering never? Because that's also a problem. What happens when it does trigger? Is it auto-closed by some other system? Because that's not useful. Again, we don't get paid by the bushel, so I don't want to know that you're auto-closing it. I want to know that you're acting on it. Is the ticket being left open forever because that keeps any other ticket from being opened? Also not okay. And I see that all the time. Is it triggering on the right things still? Because things change. Is it running the correct automation? Because that changes. Is it capturing the right information along the way? Because that changes. The reality is that tools change, and applications change, and user patterns change, and we change along the way. But the work continues. Now, I promised at the beginning that I might irritate you. It doesn't look like, I'm looking in the camera, it doesn't look like anyone is dead. Pete and Jason will confirm it for me, or asleep. So I want to thank you again for your time and for the battery lasting this long, and I am ready for your questions.
Do we want, you're going to just look at us? That's kind of weird, I guess. Yeah, I mean, turn it around.
Hi, guys! Hi!
All right.
This is amazing.
Yeah, are there any questions from the audience? I'd love to field them off to Leon. No? Yeah, I mean, it is approaching 5. All right.
Yeah, right. It's time for a happy hour. No one wants to talk.
Yeah, exactly. Well, again, as a reminder, there is a Slack channel. Leon obviously can't go anywhere, so he will be at your disposal in Slack. But now that we do have him unmuted, he was unfortunately muted during all of your great laughter. So let's first give him some great laughter for all of those hilarious jokes. And a round of applause. Leon, appreciate the flexibility during Jason's epic fuck up. We actually did a post-mortem in the back. It was not a blameless post-mortem. We realized what we did, so we did test it. We had this set up, we had audio, it was sounding great, the video worked, but it was very clearly a test and staging because we didn't power the laptop because we were just doing a quick test. So, yeah, nice one.
Amazing. Well, thank you all again, and have a great evening, and I will be hopefully back next year for this live and in person.
Awesome. Thanks so much, Leon. Really appreciate it. All right, that's going to do it for today. Reminder, all the sponsor parties are happening. Slack channel has the details around it, as well as other events that are happening are in that Slack channel. Other housekeeping items, I believe doors open here, same time, 8 o'clock tomorrow. We'll start at 9:30, so kind of following the same schedule. If you like donuts, and I believe, are there vegan donuts of these? It's good, vegan, and so there are vegan options for these donuts. Do not eat breakfast. There will be, how many hundred? 30 dozen. There will be 30 dozen, if someone could do the math. I'm clearly not. Donuts showing up tomorrow. So don't eat breakfast, you're gonna eat donuts. I'm gonna chase you around with donuts so that we get all 30 dozen done. But otherwise, have a fantastic, Jason wants to say,
they're not any donuts. Like I said, it's not like voodoo, it's Blue Star, so.
In addition to being a sandwich snob, he is a donut snob too. All right, thank you everyone so much. Day 2's in the books, and we will see you tomorrow.